cannabis-infused lotions, salves, sprays, and other skincare products known as topicals are used for their non-intoxicating effects to help with low localized pain and swelling, plus skin issues like psoriasis and eczema. Click on the boxes to learn more about the different ways that cannabis is consumed.
9:15. How am I already underwater?
I'm in the same boat.
I'm in an actual boat.
I thought...
Hey guys, welcome to Community JB here. Quick video, turning off auto rotate. I'm getting this a lot from a lot of people. How the heck do I turn off auto rotate? I don't like that feature. It's a new feature in the Remarkable Paper Pro that some people love, some people don't love. I actually turn it off or lock the screen, and I'm gonna show you how to do that real quick. Basically up here in the menu bar by your battery, okay, which is a quick menu. If you're in our planner, and you get our free planner, right, you can't get to this. So you gotta close, get back to where you work with your battery, click there, and there's a lock button. That will lock the screen where you want it to be. Again, very simple. It's one of those things that's hard to find. Click that, lock the screen, and it will come up. There it is. And then you can also turn up the brightness. Also, one thing on the new beta, if you want to get in the beta, I'm going to do a video about this. You can get the new bright mode, which has got
Smoking is one of the most unhealthy ways to consume cannabis. Burning cannabis releases harmful compounds that can also be found in tobacco. Cannabis can be smoked different ways, such as in a joint or with a pipe. Water pipes may cool the smoke before consumption, but this does not eliminate the health risks. Holding smoke in the lungs longer does not make a difference in how much THC is absorbed. Smoking is one of the most unhealthy ways to consume cannabis. Burning cannabis releases harmful compounds. That can also be found in tobacco. Cannabis can be smoked different ways, such as in a joint. Or with a pipe. Water pipes may cool the smoke before consumption, but this does not eliminate the health risks. Holding smoke in the lungs longer not make a difference in how much THC is absorbed. Cannabis is vaporized by heating it until the cannabinoids and terpenes are released as a vapor. Because the cannabis isn't burned, it doesn't release as many harmful chemicals. Chemicals or carcinogens as it would if smoked. Vaporizing requires expensive vaporizers that new consumers may not want to purchase when first. Consuming cannabis. Vaping still involves inhaling hot air and vapor into the lungs that can cause coughing. Vaping also doesn't smell as much as smoking. smell doesn't stick as much to clothes or furniture and dissipates. Much faster. Edibles offer an alternative to smoking and vaping. Edibles tested for their THC content and portioned for consumption allow consumers to measure how much they eat or drink. The effects of edibles last much longer compared to smoking cannabis, up to 12 hours for some consumers. Edibles also have stronger body effects than smoking, which could be unpleasant for some people. Edibles offer an alternative to smoking and vaping. Edibles tested for their THC content and portioned for consumption allow consumers. To measure how much they eat or drink. The effects of edibles last much longer compared to smoking cannabis. Up to 12 hours for some consumers. Edibles also have stronger body effects than smoking, which could be unpleasant for some people. Consuming cannabis extracts often requires specialized accessories. Consuming extracts, such as rosin or shatter using a water pipe, is often referred to as dabbing. Dabbing involves superheating an accessory called a nail to several hundred degrees. When the extracts are placed on the nail, they vaporize quickly, releasing a cannabinoid-rich vapor that is drawn through the water pipe. To cool. The effects of consuming cannabis extracts by dabbing are much stronger than consuming dried flower. This is not recommended for new consumers. Topicals are lotions or creams that contain cannabis. THC and CBD topicals are meant to be applied directly to the skin. The cannabinoids contained in the topical can be partially absorbed through the skin and provide localized effects. It is not possible to become intoxicated from using cannabis topicals as intended. Topicals are lotions or creams that contain cannabis. Topicals are lotions or creams that contain cannabis. THC and CBD topicals are meant to be applied directly. To the skin. The cannabinoids contained in the topical can be partially absorbed through the skin and provide localized effects. It is not possible to become intoxicated from using cannabis topicals as intended. Click on the boxes to learn more about different cannabis accessories. Pipes vary in their construction, but usually consist of a bowl, a stem, and a mouthpiece. Dried cannabis burns in the bowl and is cooled as it moves along the stem and is inhaled through the mouthpiece. Some consumers prefer pipes because they are more portable than a water pipe and are reusable and easy to pack, unlike a rolling paper. Pipes vary in their construction, but usually consist of a bowl, a stem, and a mouthpiece. Dried cannabis burns in the bowl and is cooled as it moves along the stem and is inhaled through the mouthpiece. Some consumers prefer pipes because they are more portable than a water pipe and are reusable and easy to pack, unlike a rolling paper. Water pipes, often referred to as bongs, filter smoke through water to rapidly cool it. Water pipes have a bowl that holds the ground cannabis that connects to a downstem that channels. smoke to the bottom of the water-filled chamber so the smoke can bubble up through the water and cool. Vaporizers are a smokeless method of consumption where the dried cannabis flower is heated until the cannabinoids and terpenes evaporate and form a vapor that is inhaled. Vaporizers don't get hot enough to ignite or burn the dried cannabis flower, so many of the harmful contaminants in the smoke can be avoided. Vaporizers can be large desktop devices with accurate temperature control. The vapor is either inhaled from a long tube or collected in a large plastic bag for more portable consumption. Portable vaporizers are also available. These smaller devices are normally battery-powered and vary in their features and capacity. Vaporizers are a smokeless method of consumption where the dried cannabis flower is heated until the cannabis and terpenes evaporate and form a vapor that is inhaled. Vaporizers don't get hot enough to ignite or burn the dried cannabis flower, so many of the harmful contaminants in the smoke can be avoided. Vaporizers can be large desktop devices with accurate temperature. Control. The vapor is either inhaled from a long tube or collected in a large plastic bag for more portable consumption. Portable vaporizers are also available. These smaller devices are normally battery-powered and vary in their features and capacity. Rolling papers are the thin, slow-burning papers rolled around dry cannabis to form a cannabis cigarette. Some rolling papers are sold as pre-rolled cones and are filled with dried cannabis from one end. A quality rolling paper should burn evenly and produce little to no white ash. Rolling papers are the thin, slow-burning papers rolled around dry cannabis to form a cannabis. Cigarette. Some rolling papers are sold as pre-rolled cones. And are filled with dried cannabis from one end. A quality rolling paper should burn evenly and produce little to no white ash. Grinders are tools that break up the cannabis flower into smaller pieces that burn more evenly or have more surface area for vaporizing. There are many ways to break up cannabis. Many consumers like grinders because they are portable, easy to use, and often have storage for ground cannabis. Grinders are tools that break up the cannabis flower into smaller pieces that burn more evenly or have more surface area for vaporizing. There are many ways to break up cannabis. Many consumers like grinders because they are portable. Easy to use, and often have storage for ground cannabis. Match the cannabis product or accessory with its description. Cannabis affects everyone differently. The effects of cannabis depend on the strain, how much is consumed, how it is consumed, and how experienced the consumer is. Click to learn about the mental and physical effects of cannabis consumption.
with our tank, since we accessed the player controller to disable input and disable showing the mouse cursor, now we'd like to have our own custom player controller class so that we can add functionality to it that will handle this for us. And then we'd like to create a blueprint based on this class so that we can access some of the exposed variables on the player controller, such as which mouse cursor to show once we actually start showing the mouse cursor. So we're going to create a player controller class and add enabling and disabling input functionality, and then we're going to create a blueprint and set the mouse cursor type in blueprints. Now, creating this class is something you know how to do. So you're going to create a player controller class for your challenge. Create a new C++ class and choose player controller as the parent class. Call this blueprint itself, and I'll see that player controller is an option here. So I'm going to select player controller and name my new player controller Toon Tanks editor, and it's quite simple. You go to the folder that contains the blueprint, click and drag into the correct folder, and click move here. Now, I don't want to move my projectile to this folder, so I'm just going to click here in the content browser to cancel that action. So now I have a player controller folder. I'm going to right click and click blueprint class, and in the search, I'm going to look for Toon Tanks player controller and select that class and click select. Now I can call this BP underscore Toon Tanks player controller. So I now have a player controller. Now I need to set this as the default player controller. So I'm going to go to the game mode folder, open BP Toon Tanks game mode, and open the full blueprint editor. And here I see player controller class. I'm going to click the drop down and select BP Toon Tanks player controller and compile and save and close out of that. So now we have the custom player controller class. We're ready to add some functionality to this. So what I'd like is a function here that can set the player enabled state, whether or not the player is enabled to add input that will move the tank. Now, I plan on calling this from the game mode when the actor dies, so I'm going to make a public section here, and the function is going to be void, and I'm simply going to call this set player enabled state, which can take a boolean called be player enabled. This way, if we call this function, we can either pass in true if we'd like the player to be enabled, or false if we'd like it to be disabled. So let's implement this function in toontanks_player_controller.cpp. So here's my function, and of course I need the class name here, so it's going to be a Toon Tanks player controller, and there's the scope resolution operator. Now this function is going to be quite simple. It's going to check the value of be player enabled. Either pass in true if we'd like the player to be enabled, or false if we'd like it to be disabled. So let's implement this function in toontanks_player_controller.cpp. So here's my function, and of course I need the class name here, so it's going to be a Toon Tanks player controller, and there's the scope resolution operator. Now this function is going to be quite simple. It's going to check the value of be player enabled, and we can do that with a simple if check. So I'm going to say if be player enabled, and I'd like to access the pawn and enable or disable input. And the way to access the pawn that this player controller is possessing is to use the function get pawn. This returns an a pawn, and the pawn class has the function enable input, and enable input, as we've seen, requires a player controller, so we can pass in this. Now I'm getting the red squiggles because we need to include that pawn class type. And we can easily see the include for the pawn by either going to the Unreal Engine documentation for a pawn, or we could simply go to our base pawn class, which inherits from a pawn. And because it inherits from a pawn, we've seen that it needs to include the pawn header there, so I can copy that include. It's gameframework/pawn.h. So back in Toon Tanks player controller, I can paste that include here at the top to get rid of those red squiggles. So this takes care of the case when be player enabled is true, but we also need an else case here. In the else case, we're going to call get pawn, and there's a function just like enable input that is designed to disable input, and it's called, as you might guess, disable input. And this also requires a player controller, for which we will pass in this. Now the player controller has that be show mouse cursor, and we're going to set that as well, and we'd like to set it based on whether or not the player should be enabled. So whatever the boolean value of be player enabled, we're going to set be show mouse cursor to that value. So we're going to say be show mouse cursor equals be player enabled. Now, we haven't shown the mouse cursor yet. We're going to get to that part. We'd actually like to see the mouse cursor while we're playing the game so we know where our tank is aiming. So we'll get to that soon, but for now we have this nice function in the player controller, and we'd like to call this function from the game mode. Now, to show you what I mean, I'm going back to game mode, and here's the actor dive function, and you'll see that we're disabling input and we're setting bShow mouse cursor here. So the reason I'd like to have a function on the player controller is so that we can simply call that function, passing in a Boolean value. In this case, we pass in false so that we get that disable input function called, and bShow mouse cursor would be set to false. So we can simply call that function here. Now, rather than calling tank get player controller, which returns a player controller, I'd like to have a pointer variable that allows us to access that player controller. So here in Toon Tanks game mode.h, I'm going to add a private variable. I'm going to forward declare it, and it's going to be of type a Toon Tanks player controller. That's a pointer, and I'm going to call this Toon Tanks player controller. And I can set this here in Toon Tanks game mode and begin play using gameplay statics. Now, if you were wondering if gameplay statics had a get player controller function, you were right. This is one of those handy static functions that requires. So here in Toon Tanks game statics. Now, if you were wondering if gameplay stat player controller, that's a pointer, and I'm going to call this Toon Tanks player controller. And I can set this here in Toon Tanks game mode and begin play using. Gameplay statics. Now, if you were wondering if gameplay statics had a get player controller function, you were right. This is one of those handy static functions that requires a world context object and a player index. So we can go ahead and copy the include for gameplay statics and call this here in begin play. So I see at the top here I already have gameplay statics. That's because we're using it already here in begin play to call get player pawn. We're going to do the same thing here to set the player controller pointer. Now, this is something you should know how to do. So why don't you pause the video and do a little mini challenge here and just set the value of Toon Tanks player controller. Okay, so we're going to say Toon Tanks player controller, and we're setting it equal to the result of u gameplay statics get player controller. And we know the world context object can be this, and the player index is not 9 but 0. And of course, we know that this returns a player controller and not a Toon Tanks player controller. So just like we did with tank here, we're going to cast. So I'm going to say cast to a Toon Tanks player controller, and we're casting the result of get player controller. So now after begin play, we will have the Toon Tanks player controller. And now we can come up here, and instead of getting the player controller using get player controller directly from the tank, we can check to make sure our variable Toon Tanks player controller is valid, and then we can call that function we made. Let's go back and look at it. It's called set player enabled state. And here in the game mode, we'd like to disable input and stop showing the cursor, which means we're going to pass in false for this. So we're going to say Toon Tanks player controller set player enabled state, and we're passing in false for this. And we're using Toon Tanks player controller, which means we need to include Toon Tanks player controller. So here at the top, we're going to include Toon Tanks player controller.h, and now we have this type defined. Okay, let's go ahead and compile this. And the last thing we'll do before we wrap this up is go into our player controller blueprint. And I'd like you to scroll down to the mouse interface section, state. And here in the game, we will have the Toon Tanks player controller. And we know the world context object passed. So now after begin play, we will have the Toon Tanks player controller. And now we can come up here, and instead of getting the player controller using get player controller directly from the tank, we can check to make sure our variable Toon Tanks player controller is valid, and then we can call that function we made. Let's go back and look at it. It's called set player enabled state. And here in the game mode, we'd like to disable input and stop showing the cursor, which means we're going to pass in false for this. So we're going to say Toon Tanks player controller set player enabled state, and we're passing in false for this. And we're using Toon Tanks player controller, which means we need to include Toon Tanks player controller. So here at the top, we're going to include Toon Tanks player controller.h, and now we have this type defined. Okay, let's go ahead and compile this. And the last thing we'll do before we wrap this up is go into our player controller blueprint. And I'd like you to scroll down to the mouse interface section, and you'll see that it says default mouse cursor. And we can click the drop down, and there are a number of different cursors to choose from, and I'm going to choose crosshairs. Now, we're not showing the mouse cursor yet, but once we start the game, we're going to show the cursor, and when we do, I'd like it to be crosshairs instead of the default white arrow that we always see when we look at the mouse cursor. So set default mouse cursor to crosshairs. And we'll be able to see those crosshairs once we actually enable the mouse cursor. So in summary, we created a custom player controller class, and we're using that to enable or disable input with a function that we placed on that class, and we're also using that function to show the mouse cursor or hide the mouse cursor based on the boolean passed in. And in the blueprint that we created, we set the mouse cursor type, and we're going to see very soon what that crosshairs mouse cursor looks like when we start showing the mouse cursor when the game starts. So great job, we now have this player controller, and we're ready to continue implementing game functionality, so I'll see you in the next video. Welcome back. Now we have a game mode, and we'd like to use the game mode to determine when we can start the game. Now some games have a delay or a countdown timer that starts when the game starts, and after a set amount of time, then the player is allowed to move the character, or in our case the tank, around in the world. So we're going to implement that in this video. This is going to involve first disabling the input so we can't move around when the game first starts, and then we're going to set a timer, and after a set amount of time, then we can enable input. So let's go back to Toon Tanks GameMode.h and add a couple of things here. First, I'd like to add a float for the amount of time that should pass when the game starts before we can start moving. So this float is going to be called start delay. And I'm going to initialize this to 3.f so that we have to wait 3 seconds before we can start the game. Now, as soon as the game starts, I'd like to start this timer, which means I'd like a function that will start this timer, and I'm going to make this a private function as well. I'm going to make this a void function called handle game start. Now, I can implement handle game start in Toon Tanks GameMode.cpp down here under begin play. To 3, then we can enable input. So let's go back to have a delay or a countdown timer that starts when the game starts, and after a set amount of time, then the player is allowed to move the character, or in our case the tank, around in the world. So we're going to implement that in this video. This is going to involve first disabling the input so we can't move around when the game first starts, and then we're going to set a timer, and after a set amount of time, then we can enable input. So let's go back to Toon Tanks GameMode.h and add a couple of things here. First, I'd like to add a float for the amount of time that should pass when the game starts before we can start moving. So this float is going to be called start delay. And I'm going to initialize this to 3.f so that we have to wait 3 seconds before we can start the game. Now, as soon as the game starts, I'd like to start this timer, which means I'd like a function that will start this timer, and I'm going to make this a private function as well. I'm going to make this a void function called handle game start. Now, I can implement handle game start in Toon Tanks GameMode.cpp down here under begin play. Now, I won't forget to add the Toon Tanks Game Mode class name here, and now I have a handle game start function. Now, the place to call this would be begin play, since begin play is called at the start of the game. So I'm going to call handle game start here in begin play, and since we're doing a couple of things here at the beginning of the game, we're setting the tank and the Toon Tanks player controller variables, I'd like to move these into handle game start. So I'm going to move those right down into handle game start, and that way tank and Toon Tanks player controller will be set since we're calling handle game start here in begin play. So here is where I would like to start the countdown timer, after which we can enable user input. Now, before we start the timer, I'm going to disable input so we can't move the tank just yet. And that's going to require our function we placed here in Toon Tanks player controller called setPlayerEnabledState. And that means I'm going to use Toon Tanks player controller. And if I'm going to use Toon Tanks player controller, it's a good idea to make sure it's valid. So I'm going to say if Toon Tanks player controller, and if we reach the inside of this if statement, then I can take Toon Tanks player controller and call setPlayerEnabledState and pass in false, and that way our tank will not be able to move. And I see the red squiggles, and that's because I said Tanks player controller rather than Toon Tanks. So spelling it correctly, now I get no errors there. So next, we need to start a timer. Now we know that timers involve using an ftimer handle, and we can actually create an ftimer handle rather than having a member variable that belongs to the class. So I'm going to go ahead and do that, and I'm going to call this player_enable timer handle. And next, we need to set a timer. Now, for the callback function for our timer, I'd like to use setPlayerEnabledState, but setPlayerEnabledState is a function that requires an input of type Boolean. Now, we haven't seen how to set a timer using a callback that requires input parameters. This is going to involve a new concept called a timer delegate. So let's take a look at Unreal Engine's timer system again. We know that there's a world timer manager, which manages our timers, and it has a set timer function. Now, there are multiple overloads of the set timer function. We've seen one of them already. Now I'm going to talk about another version of this function, and this version requires a timer handle, a timer rate, or a delay time during which we must wait before our callback function gets called, and instead of taking the address of a callback function directly, it can take something called a timer delegate. This is a struct of type ftimerDelegate, which allows us to create an object that can bind a function directly to it. delegates can bind functions that require input parameters. Now we can create an fTimerDelegate variable and initialize it using the createUObject function from fTimerDelegate. This will create a new timer delegate and initialize it based on what we pass into the parentheses. This will take a user object, which is of course the class that our callback function exists on, and next it takes the address of the callback function itself, followed by any input values that we would like passed into our callback once it gets called. From there, we can call setTimer from the World Timer Manager and use the overload that takes a timer delegate. This overload requires the timer handle itself, the timer delegate, the play rate or a float that determines the delay before which our callback will be called, and then a boolean to determine whether or not our timer should loop. So we know how to create an timer delegate. So I'd like you to create one in the handleGameStart function inside of our new if statement. So create a local fTimerDelegate and use fTimerDelegate createUObject. Now we're going to need to pass in a user object, and usually we've been using this as the user object, but the function we'd like called exists on the player controller. So pass in our variable Toon Tanks player controller as the first input. That's going to be the user object. And the callback function is going to be setPlayerEnabledState, that function we added to our custom player controller. Don't forget the address of operator. And as the third input, we're going to pass in the value true. This is what will be passed into setPlayerEnabledState when our callback gets called at the end of the timer. So calling set timer using our new timer delegate. And at the end of this delay time, we should get our callback function setPlayerEnabledState called with the value true passed in. Now, since start delay is 3 seconds, and we're calling setPlayerEnabledState passing in false before we set our timer, when we press play, we shouldn't be able to move until this 3-second delay is up. So let's compile this and see how it works. So I'm going to go ahead and hit play, and I'm trying to move around, and I can't, and after 3 seconds, I can suddenly move. And also check this out. Notice that my cursor is the crosshairs. It may be hard to see on the screen, but you should be able to see it on your screen just fine. And this makes it a lot easier for me to aim and control my tank's turret rotation. Perfect. So in summary, we created a handle game start function for the game mode, and we're calling this in begin play. And we also set a timer using a timer delegate onto which we bound our setPlayerEnabledState function on the player controller. This allowed us to have a function callback for our timer that takes input parameters, and we use this to enable user input after a 3-second delay when the game starts. Now, this could be frustrating for a player if they didn't have some sort of visual cue, sort of letting them know that input is not enabled, something like a countdown on the screen. So we'll take care of that in future videos, but for now, congratulations. You now know how to bind a function that takes input parameters to a timer delegate. I'll see you in the next video. Hey, welcome back. In this video, we're going to work on showing text on the screen to let us know that the game is starting. And this is the first step to showing the countdown timer to let the player know that the game has not quite started yet, but it will start soon. Now, this is going to involve blueprint implementable events. A blueprint implementable event is a C++ function that we can call from C++, but we actually implement the functionality on the blueprint side. So we may have our C++ class, such as the game mode, and we can have a function marked as a blueprint implementable event, and then we can implement that behavior in blueprints. So when we call the C++ function marked as a blueprint implementable event, then the event in the blueprint will be fired off, and any blueprint logic that we connect to that event in the blueprint will be called. So I'm going to create a blueprint implementable event function here in Toon Tanks GameMode.h, and blueprint implementable events cannot be private, so I'm going to add this to the protected section. Now I'm going to make this a void function, and I'm simply going to call this start game. Now, in order to make this a blueprint implementable event, I have to give it a uFunction macro with the uFunction specifier blueprint implementable event. Now, once we mark this blueprint implementable event, we don't even need to give it a function body here in C++. Unreal Engine will expect us to implement the function specifier blueprint, give it a uFunction macro with the uFunction specifier blueprint implementable event. Now, once we mark this blueprint implementable event, we don't even need to give it a function body here in C++. Unreal Engine will expect us to implement the functionality for this in blueprints, but we can call it from C++, and that's exactly what we're going to do here in handle game start. So just after we've set the tank and the player controller variables, I'm going to call start game, and now we can compile this. And hopping back here in the editor, I'm going to open BP Toon Tanks game mode, and here is where we can implement the function. So if we right-click and type start game, then here is the event start game that was created as soon as we declared the here in handle game start. So just after we've set the tank and the player controller variables, I'm going to call start game, and now we can compile this. And hopping back here in the editor, I'm going to open BP Toon Tanks game mode, and here is where we can implement the function. So if we right-click and type start game, then here is the event start game that was created as soon as we declared the function and gave it the uFunction macro with blueprint implementable event. So on the C++, I'm going to open BP Toon Tanks game mode, and here is where we can implement the function. So if we right-click and type start game, then here is the event start game that was created as soon as we declared the function and gave it the uFunction macro with blueprint implementable event. So on the C++ side, we're calling this, and in blueprints, this event is responding to it. We can test this out with a simple print string node, and for the string, we can say start game. Now, if we hit play, I'll see start game at the top left. So we know that our blueprint implementable event is working. Now, what we'd like this event to do is to show a widget which contains text informing the player that the game is about to start, which means we need to create a widget to show. So I'm going to create a new folder in the blueprints folder, and I'm going to call this widgets. And I'm going to double-click widgets, and here is where I'm going to create a new widget blueprint. Now, if I right-click and go to user interface, here is widget blueprint. Now, if I click this, I'll create a new widget blueprint, and which means we need to create a widget to show. So I'm going to create a new folder in the blueprints folder, and I'm going to call this widgets. And I'm going to double-click widgets, and here is where I'm going to create a new widget blueprint. Now, if I right-click and go to user interface, here is widget blueprint. Now, if I click this, I'll create a new widget blueprint, and I'm going to call this WBP for widget blueprint underscore start game widget. And if I double-click this, then I'll open the widget blueprint editor, and you'll see that it looks quite a bit different. Now, if I right-click and go to user interface, here is widget blueprint. Now, if I click this, I'll create a new widget blueprint, and I'm going to call this WBP for widget blueprint underscore start game widget. And if I double click this, then I'll open the widget blueprint editor, and you'll see that it looks quite a bit different than the blueprint editor we're used to seeing. And that's because this is for a widget. Widgets are good for displaying things on the screen like text. Now there's a lot here, and we're only going to make a very basic widget that shows text. There are a number of different types of elements we can add to a widget blueprint, such as borders, buttons, game widget. Now if I is about to start, click and go to user interface. Here is widget blueprint. Now if I click this, I'll create a new widget blueprint, and I'm going to call this WBP for widget blueprint underscore start game widget. And if I double click this, then I'll open the widget blueprint editor, and you'll see that it looks quite a bit different than the blueprint editor we're used to seeing. And that's because this is for a widget. Widgets are good for displaying things on the screen like text. Now there's a lot here, and we're only going to make a very basic widget that shows text. There are a number of different types of elements we can add to a widget blueprint, such as borders, buttons, checkboxes, images, and so on. But what we're interested in is this one right here, which says text. Now look down here in the hierarchy panel, you'll see that we have the overall WBP Start Game widget at the top, and if we click on that, we can change properties for this widget. Now we can drag in widget elements onto this hierarchy. So I'm going to search the palette for Canvas panel and drag that down into my hierarchy. Now Canvas panel allows us to place widget elements and set them at a desired location on the screen. So we can drag a text element straight onto the graph, and you'll see in the hierarchy this new item under Canvas panel, and it says text block. Now this text block in quotes is the text that's automatically set for this text widget. And here in the details panel with this text widget selected, under content we see a text property, and it's set to text block. But we can set this to any text we want, such as get ready. Now after setting this to get ready, you'll see that the text here on the screen says get ready. So the widget blueprint editor allows us to customize our widgets. Notice at the top left of the screen, this medallion thing here, this is called an anchor. Our text widget is placed on the screen relative to the anchor. So if the screen size changes, the distance from that anchor will remain constant, and we can change the anchor if we want to. For instance, we can set our text widget relative to an anchor in the middle of the screen by going over to the details panel, and under slot we see anchors, and if I click the drop down, I can select this icon, which has a square in the middle. If I select that, now the anchor is in the center of the screen. And if I want my widget completely centered, I can change its position X and Y here under the slot category. So I can set this to 0 for position X and 0 for position Y, and scrolling with my mouse wheel to zoom in, you'll see that its upper left corner is in the middle of the screen. Now this alignment field here can let us center this perfectly by choosing values of 0.5 for X and 0.5 for Y, and now it's completely centered in the middle of the screen. Now for a start game widget, it's probably going to be appropriate to put this text a little bit higher up. So for position Y, I can click and drag this to the left, which will make that position Y value negative. In the widget blueprint editor, the Y-axis points downward, so if we want to raise our text widget up, we're going to make that position Y a lower value. I'm going to place it up here at about -300. Now down in the appearance category, I can change a number of properties for this text. If I click the drop down for font, I can change the font size to say something like 42. Now for typeface, instead of bold, I like the regular typeface. I think it looks a bit better. Now notice that our text widget text is larger than the green rectangle here, but we can resize this green rectangle. And as I'm changing the rectangle, you'll see here in the details panel that size X and size Y are changing. Now notice position X has moved a bit since I've changed it. I can put it back to 0, and since alignment for the X is 0.5, it's perfectly centered. So now I have a widget that says get ready. The only thing left to do is to add this to the viewport so we can see it on the screen. You'll notice that if I hit play and start playing the game, that I do not see that widget on the screen. That's because we have to actively add this to the screen, and that's why we created this blueprint implementable event in the game mode so that we can add this widget to the screen here. So let's talk about how to do that. Now the way to create a widget from blueprints is by the use of a create widget node. You can right click in the event graph for any blueprint and start typing the name of a node, and then select that particular node. The node we need is create widget. Now you'll see that it says create WBP coolness widget, and that's because as soon as I added the create widget node, I selected the widget blueprint class here in the class dropdown. This is necessary so that Unreal Engine knows which widget class to create. Now after using a create widget node, we use an add to viewport node to actually add this widget to the viewport, and then we can see it on the screen in the game. Notice that the execution wires are connected, and also that the create widget node returns this blue output, and this should be connected to the target input in add to viewport, since add to viewport needs to know which widget to add to the viewport, and the create widget node returns the value of that widget. So now that you know how to create a widget in Blueprints, you're going to go into the BP Toon Tanks game mode class and use a create widget node. You're going to hook this up from our blueprint implementable event execution wire that we called start game. Now in the create widget node, we need to select the widget class to create. So select WBP start game widget, that new widget blueprint that we just created, and then use an add to viewport node to actually add this new widget to the viewport and hook up the execution wires. And don't forget to hook up the return value from create widget to the target input and add to viewport. So pause the video and add these nodes to the Toon Tanks game mode blueprint now. So I'm here in the Toon Tanks game mode blueprint, and I'm going to right click and type create widget and choose the create widget node. Now notice it says construct none, and that's because it's going to say that until we select the appropriate widget class in the class dropdown. But before I do that, I'm going to hook up the execution wire from event start game so we actually get this functionality executed as soon as our blueprint implementable event start game is called from C++. Now for the class dropdown, I'm going to select WBP start game widget, and now the node's title changes to say create WBP start game widget widget. So now we can see that this is a create widget node. Now I'm going to click the execution wire and drag out, and then type add to viewport. And then if I select add to viewport, then the execution wires are automatically connected for me. But it doesn't connect the return value from create widget to the target input for add to viewport. So I need to click and drag that myself. So now when start game gets called from C++ in the game mode class, we will execute this blueprint logic, which will result in creating a new widget based on WBP start game widget, and then we will add it to the viewport. So I'm going to click play, and there's the get ready widget. Now we mentioned that this is going to show a countdown timer, but we haven't implemented that functionality just yet. So that's coming soon. So in summary, we created the start game widget blueprint, and for now it just has text on it that says get ready. We also used a create widget node and an add to viewport node to add this widget to the viewport so we can see it as soon as the game starts, and we initiated this functionality using our blueprint implementable event that we created in the game mode C++ class called start game. In the videos to come, we're going to change the text in this widget at runtime so that it shows how much time is left on that start game timer so the player knows how much time to wait before they can start actually playing the game. I'll see you soon. Hey, welcome back. In this video, we're going to create a countdown timer so that the player knows how much time they have to wait before they can start moving their tank around and blowing stuff up. So we're going to show the time left in the countdown timer until the game starts. So let's hop into the editor and start doing this. Now I'm here in our widget blueprint, WBP start game widget, and this is the widget editor as we've seen, but you may have noticed at the top right, there are two tabs here, one that says designer, that's what we're in right now, and one that says graph. And if you click on graph, it looks more like a blueprint event graph with event nodes and a my blueprint tab here with various sections, and this is where we can do blueprint logic. Now we have three nodes here. We have event preconstruct. This is similar to a constructor in C++, and then we have event construct, which is similar to begin play. So this is where it's more appropriate to do things at the beginning of the game because all relevant classes are constructed by this point. And then we have event tick. And just like the tick function in C++, we have access to delta time here. Now we're not going to use the first two nodes, so I'm going to highlight those and delete them, and we're going to use event tick. Now our goal for this video is to show how much time is left, and we have a 3-second countdown timer. Now in C++ we created a timer handle, and we used the world timer manager to start a timer. Everything we do here in blueprints is independent of that. We're creating a completely different system of logic here, and it's just going to coincide with that timer that we set in C++. So this is all different and independent from the C++ side. Now here in WBP start game widget, we can add variables just like we can add variables in C++. Right here under my blueprint, I can click add and select variable, and now I have a variable called newvar_0. And down here in the details panel, which is confusingly on the left side now, we have the variable name and variable type. Now, it's highlighted by default because it's just expected that you're going to rename your variables as soon as you create them. So we don't need this default name. We're going to call this our own name. I'm going to call it countdown. And countdown is going to be a float variable. Why? Because this is going to keep track of how much time we have left. I'm going to start it off at 3 seconds, and each frame I'm going to subtract the amount of time that's passed since the previous frame, so we get a countdown going from 3 downwards. Now I'm going to click compile. Now as soon as I click compile, I can give this a default value by scrolling down in the details panel. It's set to 0 by default. I'm going to set it to 3 by default since we have a 3-second countdown time. Now, as it stands, this is just a float called countdown with a value of 3. We haven't actually changed it, but every single frame of the game, I'd like to subtract away delta time, which is the amount of time that's passed since the previous frame. And that way, countdown will constantly be updating, decrementing by delta time, so that we have a running time count. Now, here's how we can do that. I'm going to take a countdown from our My Blueprint tab, click and drag it here into the event graph and release. Now, as soon as I release, I have two options, get countdown and set countdown. If I click get countdown, now I have the countdown node, and if I click and drag out of its output, this gives me access to the value of countdown. Now I can also click on countdown, drag in, and click set countdown, and we have a set node. We've seen these both before in earlier videos. the input pin for the setter allows us to plug in a float value, and then countdown will be set to that value. So how do we actually subtract delta time away from countdown and then set that to the countdown value? Well, we can take our countdown node here, and I can click and drag off of it and type the minus symbol on my keyboard and choose the subtract node. If I select that, then I now have a float minus float, or a subtract node. You'll see that it says target is Kismet Math Library. That tells you that Kismet Math Library underpins this node. All nodes have C++ code at their core. So what this node does is it takes two inputs. It takes a float input and it takes a second float input. Now, it's not going to change any of the variables we're passing in. It's simply going to perform a calculation and return that value that is the result of the subtraction. Now, I'd like to take countdown and subtract delta time from it. So I can take the output pin called in delta time from the event tick node and plug that straight in to the second input in my subtraction node. So what I'm doing is I'm taking countdown minus delta time, and then this gets the result. Now, initially countdown is 3 seconds, and delta time is a very small value. It's the amount of time in seconds that's passed since the last frame. So this will be a tiny amount. So what will result the first time this is executed is 3 minus a tiny amount. And what I'd like to do is set the value of countdown equal to that result every single frame. So each frame, countdown is being subtracted from little by little, and that way it will keep the countdown from 3 seconds going downward. So I'm going to take the return result from this subtraction node and plug it into the input for the set countdown node. Now, this isn't going to do anything if I don't connect the execution wire from the event tick execution pin to the input pin for set countdown. So now what this is doing is every single frame subtracting delta time from countdown, taking that result and setting countdown to that new value. Now we can see how this behaves with a print string node. So I'm going to drag off of the setter, type print string, and get a print string node, and then I'd like to print the value of countdown. So I can take the return value from the setter, which will give us the new value of countdown each frame, and plug it into the in string node. And notice I see a convert float to string, and if I release, now I get a conversion node that will take my float, convert it to a string, and now we can print that to the screen. Now let's see what happens if I press play. Check that out. We see that count is being decremented each frame, and we're spamming the screen with the value of countdown, and it's getting more and more negative. So this is the first step to getting our countdown timer working. I'm going to close this. Now, we saw that we're printing a float value, which has a bunch of decimal points, and once we print the value to the screen, we don't really want decimal points. We'd like an integer. So I'd like to see the amount of seconds left without those trailing digits to the right of the decimal point. So what I need is an integer. Well, what I can do is I'm going to delete this conversion node, and I'm going to take the result of the countdown setter, and I'm going to type CEIL, seal, which is short for ceiling. The ceiling operation is going to take a float value and round it up to the nearest integer. So if we're at 3, well, there's no need to round. It's going to return an integer with a value 3. But if we're at 2.9, for example, then the seal node is going to round it up to 3. And as that value decreases, it's going to continue returning 3 until we get down to 2. So we're always going to get an integer. Now I can plug this into print string, and you'll see that it says convert integer to string. So now the seal node is taking a float, rounding it up to the nearest integer, and returning that integer value. So now if I hit play, we'll see that we get 3, 2, 1, and 0. And of course, it continues going down because we never tell this to actually stop. But this is a great start because now we have access to the number of seconds left, and we can print something to the screen in response. So how are we going to print the correct message to the screen? What I'd like to do is, when we have 3 seconds left, I'd like the widget to say get ready. When we have 2 seconds left, I'd like it to show the number 2. When we have 1 second left, I'd like to show the number 1. And when we have 0 seconds left, I'd like the text to say go. Well, we can do this with a switch node. Switch nodes can switch on a number of different types, including int. Now, the way that a switch on int node works is it has a number of cases for a number of values, and based on the value that we pass into this switch node, it will do one of a number of things. For example, if we pass in the integer value 3, then we get the 3 case, which will result in thing 3 being carried out. So the switch on int node has multiple lines of execution, and it will only execute one of them based on the input. Now we can use a switch on int node and pass in an integer. For example, the result of our seal node. So I'm going to remove the print string, and I'm going to drag off of the countdown node and type switch on int and select switch on int. Now notice it takes a input of type integer. I'm going to pass in the return value from the seal node. And also notice that we have an add pin option. If we click on that, you'll see that we get a default pin in addition to the output that says 0. What this says is if we hook up some blueprint logic from the 0 execution pin, then that logic will be executed if the input value passed in is 0. And if it's not, well then it will default to this execution pin. Now we can click add pin again, and now we have 0 and 1. So we can have 2 lines of execution, one for 0 and one for 1, and then if the input is not 0 or 1, then whatever's hooked up to default will be executed. I'm going to click plus again 2 more times, so we have cases 0 through 3 and a default case. So now it's up to us to drag off of this and add some blueprint logic that we would like executed based on the value passed in that we're getting from this seal node. And that's what I'd like you to do for your challenge. I'd like you to print different messages for each case using a print string node. For the value 3, you can print get ready using a print string node. For the 2 case, you can simply print the value 2. For the 1 case, you can print 1. And for the 0 case, you can print go. Now for the default case, simply print start game with our print string node. Pause the video and add a whole bunch of print string nodes in the event graph now. Okay, so I'd like to go ahead and use a print string node, and I'm going to start down here at the bottom for the default case, and I'm going to type print string, and the string I'd like to print is start game. Now here's a shortcut if you didn't know. With the print string node selected, I can hover my mouse somewhere else in the event graph and hit Control D, and that will copy the node that I had selected. I'm going to hook up the 3 case to this print string node, and I'm going to type get ready, so when the input to the switch is 3, we'll see get ready printed to the screen. Now I'm going to Control D again and hook this up to the 2 case, and for 2, I'm simply going to print 2. Now I'm going to copy the print string node, and for 1, I'm going to print the value 1. And finally, one last print string node here is going to be hooked up to the 0 case, and this is going to say go. Okay, so let's go ahead and compile this, and I'm going to hit play, and now I see get ready, 2, 1, and go. And then of course we see start game once we've ran out of time, so we know that the value is decreasing and becoming more and more negative, but that is the default case for our switch, and that's when we know we can actually start the game. So this is the first step to showing our countdown timer in our widget. We're not quite changing the text that says get ready just yet, but we'll be doing that soon. So in this video, we created countdown logic and added that to our widget blueprint. We used print string to show our countdown values and print a different message based on our countdown values. We still need to set the text in the widget, and we're going to do that in the next video. I'll see you soon. Hey, welcome back. We are ready to show our countdown time in the actual widget. So far, we're only using print string nodes so that we know how much time is left, but we need to actually set the text in the widget. So we're going to show the countdown time in the widget in this video. Now, I'm back here in WBP Start Game widget, And we saw that we added some text to this widget, and there are a couple of things we need to change with this text widget so that we can edit the text dynamically. The first thing I'd like to do is, with the text widget selected here in the details panel, there is a name for this text, and it's set to a default name, which is not very descriptive. So I'd like to rename this, and let's call this display text. Now, right next to this text block, we can see this checkbox that says is variable. Now, it's not checked, and if we go back to the event graph section, we don't see this text widget as a variable here, but if we go back to designer and check this text box is variable, then once we go back to the graph, we'll see that display text is now visible in the variables section, and we can click and drag off and click get display text here, and now we have access to this node, which means we can change the text. Now, I'd like to drag this down to case 3 in our switch statement, where we're printing the string get ready to the screen. Now, instead of using a print string, I'd like to set the text for our text widget, and I can do that by dragging off of its output pin and typing set text, and here we see a set text in parentheses text node. If I click that, then I get a set text node, and here is an input called in text. Now, it takes an input value of type text, but we can also click the text box here and hard code the value we'd like to set the text to. So I'm going to type get ready, and rather than using this print string, I'm going to remove that print string and drag the case 3 execution wire into the input execution pin for the set text node. Now, if I compile and hit play, I'll see that it says get ready, which is the same text that it was before, so it doesn't look any different, but we can prove that it is using the text in the set text node by changing this. I'll add a couple of exclamation points, so there are 3 of them, and now if I hit play, I see 3 exclamation points. So this node is in fact setting the text for our text widget. So I'm going to challenge you to set the text so that we can print a different message for each of the cases in our switch statement. For 3, you can leave it at get ready. For 2, print the text 2 to the screen. For 1, print 1. And for 0, I'd like you to print go. Now for the default case, which is when we've run out of time, just print an empty string, which means you can leave that input text box blank. So pause the video and remove those print strings and replace them with a set text node, and don't forget to plug in the input to the set text node, the value from our text widget. Pause the video and do this now. use this set text, I'm going to use the 0 case. I'm going to just hook it straight up to the set text node, and rather than printing go with a print string, I'm going to print go by setting the text. Now I need to set the text, this set, and remove that print string. I can and simply compile. So that's exactly what we were after. Now, a couple of things. One is I'm going to go back to the Designer tab and scroll down with the text selected. I'm going to scroll down to the appearance, and you'll see that we have this justification, and it's justified to the left, which is why the 2 and 1 get printed slightly to the left. But if I select Align Text Center, now if I hit play, I'll see that my text is aligned to the middle. Now we can give our text a shadow. Here we see shadow color. We can select that, and we can give the text its own shadow. The alpha is set to 0, but if I drag it up to 1, now I have a shadow, and now our text will have a black shadow. If I click play, then I can see that my text is a little bit more visible thanks to that shadow. So this is great. Let's go back into the graph tab, and we now know that we're setting the text based on our countdown time. Now this is all still happening every single frame of the game since this is hooked up to the tick event. But the truth is, we really don't need this widget to even exist after the 3 seconds are up. If there were a way to get rid of this entire widget and remove it, that would be more ideal than simply setting the text to an empty string. So to do that, what we can do instead of setting the text is we can remove this widget from the viewport, and to do that, we use a node called remove from parent. So creating a remove from parent node and deleting the set text node, then when we hit the default case, which is when that 3 seconds is up, then this node will result in the widget being removed, and none of this tick functionality will be happening anymore because the widget will be gone. So this takes care of removing the widget once the timer is up and the player is able to start playing the game. So we have now showed the countdown time in our widget, which means that it's very clear when the game is starting and how much time has to pass before the player can start moving the tank around. This is great. So back to our section plan, we see that we've created our tank that can move throughout the world and handle input. We've created an enemy turret class called Tower in C++, and we've added fire functionality with projectiles. We have health and damage, as well as destruction in our game. Now we still need to add special effects, and we need to show when we win or lose the game using HUD displays. We've now seen how to use HUD displays, so this should be a relatively simple task. So we're almost done with this game. Congratulations. I'll see you in the next video. Hey, welcome back. In this video, we're concerned with winning and losing conditions. This is one of the last things we're going to handle in this game project. Now, let's take a look at our section plan. Now, we've already checked off the first 5 items on our section plan, and the last 2 are the special effects and winning and losing conditions. And I'd like to switch these last 2 around and handle winning and losing conditions just because this is the last of our gameplay programming logic, and the special effects are cosmetic and more like finishing touches, so we can handle those at the very end. So in this video, we're going to create a game over function so that we know when the game has been either won or lost. And in order to win the game, we're going to need to count the number of towers in the world, because once we've destroyed all of the towers, then we know we have won the game, and if the tank itself gets destroyed, then we can consider that to be the lose condition. So I'm back here in the game mode, and the first thing I'd like to do is create another blueprint implementable event. We have this start game function, which we can call from C++, but we're implementing its logic in the game mode blueprint, thanks to blueprint implementable event. I'd like to create another one of these for losing the game, so I'm going to create a void function called game over. And for this one, I'd like to take a Boolean input parameter called b1game. And of course, this is going to be a blueprint implementable event because the only thing I'd like to handle with this function is displaying that we've lost or won the game, and that we can do from blueprints. So we have a game over function. Now we need to know when we should call this function. Well, first of all, we know we can call this function when we've lost the game, and that's going to be if the tank has died. So let's go into our actor died function here in Toon Tanks gamemode.cpp. And we see that if dead actor is the tank, then we're handling the destruction of the tank, and we're setting the enabled state to false. Another thing we can do here is end the game by simply calling game over, and this Boolean b1 game, we can pass in false for this. So that takes care of losing the game, at least from the C++ side. Now we need to know when we should win the game. Now here in actor died, if the dead actor can be cast to a tower, we know that we've just destroyed a tower. Now this would be the perfect place to update a tower count, or a variable of integer type that keeps track of how many towers in the world there currently are. Now in order to do that, we need a variable to keep track of the number of towers. So we can add a private variable here in the .h file, and I'd like to do that down here. So I'm going to create an int32, and I'm going to call this target towers. Now we can initialize this right off the bat to a value of 0, but we need to update this as the number of towers decreases. And we also need to set this to the number of towers there are in the world. Now we could hard code this to 4, but what happens when we start adding more towers to our levels? Well, then it gets a little bit more complicated. So what I'd like to do instead is see how many towers in the world there are. Now I could create a function for this that returns an int32, and this function can find out how many towers there are in the world and return the number. So I'm going to call this function get target tower count. So let's go ahead and give this function a body in the CPP file. I'm going to go all the way down to the bottom and create the function body, and I can't forget to put the class name before the function name. Now this is going going to return an int 32, and we need to decide how we're going to find out how many towers there are. Now, there's a function that exists in gameplay statics called getAllActorsOfClass. Here's the documentation. It says find all actors in the world of the specified class. So we need to specify a particular class. Now, this function has 3 inputs. First is a world context object. That one's easy. We know how to handle that. But next we have a T subclass of a actor, and this is called actor class. Now we've seen that functions that require a T subclass of can accept a U class as inputs. And the third parameter is a T array. It requires a T array of actor pointers, and this is passed in as a reference, and it's not a const reference, which seems to suggest that this function just might change this input parameter called outActors. Another hint that this is the case is that it's called outActors. It's an out parameter, meaning we pass it in, and then after the function has been called, it has values that have been put into it by the function, so we can think of it as a sort of output for the function. Now it says down here for parameters, actor class is the class of actor defined. It must be specified or result array will be empty. We want to find all of the towers, and outActors is an output array of actors of the specified class. So once we've called this function and passed in an array, when the function has finished, that array will contain pointers to all of the actors in the world of the specified class. So we know that this function requires a world context object. Now if we're going to be calling this from within the game mode, we can pass in this. Next we need the T subclass of specifying the A actor, and we know that this can be a U class pointer. Now we need to specify the class to find. If we specify A actor, then we'll get a big array filled with pointers to each actor in the world, but we don't need all of the actors, we just need the towers. So we can use A tower static class, which will return us a U class that represents the A tower C++ class. Now the third parameter is a T array of A actor pointers. So if we create a local variable of type T array specifying the A actor pointer in the angle brackets, then we can call uGameplayStatics getAllActorsOfClass, passing in those 3 inputs. And the result of this action will be that our towers array should contain pointers to all towers in our world. Now the T array is a nice container class, which can contain a number of elements as long as they all share the same type. And this class has quite a great deal of functions that we can use when storing items in a T array. Now I'm going to scroll all the way down and show you this function here called num, short for number. And it says return of class, passing in those 3 inputs, and the result of the same type. And this class has to get the number power count as an int32, this get target tower parameters. Now after you call this, pause the video and implement get target tower count now. Store, and I'm going to need to make sure that that header is included. Now I see that it is, since we're using it in some of our world context object. I'm going to pass in this. And next is the T subclass of representing the act that we can use, and final parameter is going actors of first input is a world context object. I'm going to pass in this. And next is the T subclass of representing the actor class. And I mentioned that we can use a tower static class, which will return a U class that represents the tower class. Now again, it's a good idea to make sure that we're including tower.h, which we are. Now the third and final parameter is going to be the T array, and we can pass in towers. So once this function has been called, towers will now contain pointers to all of the towers in the world. In fact, if there exist any objects of a class types from towers, we would also get those. So since we have a towers array, we can simply return the number of elements in that array. So I'm going to use a return statement and use towers.num. And now we have a get target tower count. So this is great. We can use this to initialize our tower count, which we called target towers. And we can do that when we start the game. So I'm going to place that here in handle game start. In fact, I'd like it to be the first thing we do. So I'm going to take target towers and set it equal to the return value from get target tower count. Now target towers should be initialized to the number of towers in our world. So this is great, but we need to update this count every time a tower dies, which means we need to go into our actor died function. And here, if we've cast dead actor to a destroyed tower, then after we handle destruction, we should update our target towers variable. So we can say target towers, and we can use the decrement operator. We can use either the post decrement operator or the pre-decrement operator. Both of these will result in the same action, which is taking target towers and subtracting 1 from it. Now, as soon as we've subtracted 1 from target towers, now we need to check to see if target towers has reached 0. So I'm going to place an if check here to see if target towers has reached 0. Now, as soon as it does, we know that the game should be over. So we can call the game over function, passing in true for B1 game, since we've destroyed all of the towers, and we can consider this a win. Now, let's go ahead and compile our code. Now, back here in the editor, what I'd like to do before we wrap this video up is go into our game mode blueprint. So here's BP Toon Tanks game mode, and we have this event start game. And what we're doing is creating our start game widget, adding it to the viewport so that we can see that start game countdown timer. So we know that start game is being called, but we also need to implement our game over blueprint implementable event. So I'm going to right click and type in game over, and here's our event game over. And check this out. Notice we have this one game and it's a Boolean. So when we call this function from C++, we're passing in a Boolean value for B1 game. The blueprint event node strips out that lowercase b and places a space between 1 and game as sort of a courtesy for us. Now we're going to create some widgets so that we can see when we've won or lost the game, but we'll do that in a future video. For now, I just want to confirm that this is being called and called correctly. So I can do that with a print string node, and we can print the value based on this Boolean. If I click and drag this Boolean straight into the in-string input, we'll see that there's a convert Boolean to string. This is another convenient conversion node that will convert a Boolean into a string for us, and its functionality is such that it will convert to the word true or false based on the truth value of the Boolean. So why don't we test this out? I'm going to compile and hit play. All right, now I'm ready to try to win the game. Hopefully I don't lose before I can do so. And I've lost the game. And you can see false printed up at the top left of the screen. So we now know that losing the game results in event game over being called with false being passed in. We need to make sure that true is passed in when we win the game. So let's try to kill all of the turrets. So I need to really try not to get hit. Oh, I got hit already. This is pretty challenging. And there we go. And true is printed at the top left of the screen. It only shows up for a few seconds, so you might have missed it. Okay, great. So now we have winning and losing conditions. The next step is to actually show this in the form of a widget on the screen so that we're not relying on the print string node. So in summary, we now have winning and losing conditions. And there's just a few things we need to do to polish this, such as creating widgets that inform the player that they've won or lost a game. We also counted the number of towers using a TArray and the uGameplayStatics function, get all actors of class. Great job. This game is really coming along. In the next video, we'll create those widgets, and then we're ready to start adding special effects and polishing up our game. I'll see you in the next video. Hey, welcome back. In this video, we're going to work on a widget for displaying the win-lose condition. So let's jump right in. Now we have our widget, WBP Start Game Widget. Let's open that, and we'll see that we have this Get Ready text, and in the event graph, we're setting this in event tick. Now, aside from all this stuff, what we have here in the Designer tab is exactly what we need for the game over text. So we can duplicate this blueprint and change a few things. I'm going to close out of it, and here in the content browser, I can right-click on this WBP Start Game Widget blueprint and duplicate. Now we need to choose a new name for this widget. I'm going to call this End Game Widget instead of Start Game Widget. So renaming this, we now have WBP End Game Widget. Let's go ahead and double click this, and we have the same text, Get Ready, and it's called Display Text, and it's set to is variable. Now let's go into the Graph tab, and we don't need any of this blueprint logic, so we can highlight everything and delete it. In fact, we can delete the countdown variable. You can always and we don't need any of this ready, and it's called Display Text, and it's set to is variable. Now let's go into the Graph tab, and we don't need any of this blueprint logic, so we can highlight everything and delete it. In fact, we can delete the countdown variable. You can always delete a variable by selecting it here and hitting the delete key. So let's leave the display text, we need that one, and we can click compile, and now we need to figure out how to set the text for this widget. Now let's go to our game mode blueprint. Here we have event game over. This is where we can add the widget to the viewport. So I'm going to highlight these nodes, the print string and the bool to text conversion node, and delete those, and use a create widget node to add our new end game widget to the viewport. So I'm going to drag off, type create widget, and get that create widget node. Now for the class, I'm going to select end game widget. So we have WBP in-game widget, and the next thing to do is add it to the viewport. So I'm going to click and drag off of the output execution pin and type add to viewport. And now I can't forget that I need to take the return value from create widget and plug it into the target for add to viewport. So now as soon as our game over blueprint implementable event gets called, we will be adding this widget to the viewport. Now the last thing to do is to set its text based on whether or not we've won the game, which we know because we have this boolean from our event game over. So we need to think about what to do once we've won the game. Now we know that we can use a set text node to set the text of a particular widget in our widget blueprint. We need to be able to access that text widget, which we called display text. So what we can do is from our create widget blueprint, the return value, which returns a WBP endgame widget object reference, can be used to access variables in that widget. So let's click from the return value and drag off and type display text, and we'll see that we can get display text. From there, we can use a set text node. So let's click the output from display text, drag off and release, and type set text. And we can see that set text parentheses text is an option here. Now just to test this out, just after we've added the end game widget to the viewport, we can hook up the execution pin to a set text node where we can set the display text value. So for now, I'm just going to type game over, and now with a compile, I'm going to play test this and see if we can get that widget showing up on the screen. So I'll go ahead and let these turrets kill me, and now I see game over. But for me, that's not quite enough. I'd like to see if I've won or lost the game. Now there are various ways to do this, and you may even think that you have an idea in mind regarding how to set this text value. In fact, you might even wish to pause the video and see if you can implement this yourself. So if you feel like the challenge, go ahead and pause the video now and see if you can figure this out. Okay, so if you figured this out, congratulations. You have implemented the game over widget. Now I'm going to show you a special node that I'm going to use, and you may not have seen this before, but this node is called a select node. I'm going to right click and type select, and if I select, I have this node that takes an index. The index is a value which will determine what gets selected and returned as the return value, and I can click the drop down and select Boolean, and for the return value, I can right click on it and select change pin type, and then I get this drop down that says wildcard, and I can change this to a different type of output value such as text. So I'm going to select text, and now I have this select node that has a true and a false input as well as the index, which is a Boolean, and the true, false, and return values are text values. They have the text data type. Now the way the select node works is we have an index, and we selected Boolean as the type for this input, which means we can plug in a Boolean value, and the return value will be different depending on the value of the index. If the value of the Boolean is true, then we will return a text value depending on the true input for the select node. And if it's false, we'll get the value assigned to the false input. Now, these are input pins for true and false, so we can plug in text values to them directly, or we can hard code them in the text boxes. For example, we can type in text "you lost" for false and "you won" for true, and what we get returned from the select node depends on that input index. If it's true, then the return value will be "you won," and if it's false, we will get "you lost." So if you haven't implemented the solution already, I'd like you to try using the select node to do so. So use a select node and set the false text to "you lost," set the true text to "you won," and hook up the player won boolean, which we get from our game over event, resulting from our blueprint implementable event game over. Once you've done this, use set text to set the widget text. Pause the video and implement this now. Text is true or false. If it's true, I'd like to print point. Now the return value, well, I'm going to hit play, and I'm first going to try to win the game. So I'm going to try really hard not to lose. There's the first, second, there we go, and I see I won. Now I can go ahead and try the lose condition, which should be pretty easy. I just have to get shot twice. There's one, and there's two, and you'll see that my tank disappears, and I've lost the game. Perfect. So this takes care of the winning and losing conditions. So in summary, we have displayed the game over status to the player, and we're showing that in the form of a text widget. We now have a functional game, so this is a huge milestone. The only thing left is the special effects. We need some sound effects, and we need some explosion effects, and some weapon trails and things like that. So we're going to wrap up this game by adding those effects and polishing the overall game in the videos to come, so we're almost done with this section. Great job, and I'll see you in the next video.
tutorial, we're gonna center and focus specifically for Windows. So we have a whole bunch of settings here, but first of all, before touching anything on this, we're gonna go into the packaging settings of the project overall.
So let's click here, and now you can see that if we go down, the only thing that we have to make sure is that the build configuration is how you want. In this case, we have different options as debug game, development, test, shipping, etc. So normally, if you're gonna upload a game to itch.io, it's probably gonna be shipping, as you don't want the players to see your prints, your special debug commands, and so on. Now, if you want players to specifically test, like you can then put it in development, but be aware that they will see the prints that you have. I will be able to access some specific commands in your console and so on. So you want to hide everything, just be more professional, just like final ship game. I would recommend to be shipping, even though you have a very common mistake. As you can see, if we go a bit down, we can see that we have the packaging settings for our maps. In here, in this list of maps to include in a package build, we have to add your new map and basically choose the map file in your computer. And this is done manually because imagine that you have a lot of test levels or levels in progress, and they're very big. It's just to not build and export unnecessary levels that you don't need. So in this case, it is very important. You have to include what maps you want to export. In my case, I have the main menu and the game level. So that's pretty much what we have to do. Now we have more things, as for example the separate platforms. You can use and tick the ones that you don't need, and then we can go down until we see platforms. You can select your platform and then just change some things as the DirectX version, the compiler version, and so on. And then things as the game splash and game icon, which I recommend to change, as it will just make your game a bit more professional. You can see the dimensions that you need, and etc. Anyway, with those settings done and set up, you can just go back into the platform section. Just go to your preferred platform, which in this case I guess it will be Windows or Mac, but mostly Windows, and then select your configuration. In this case, you can use the price setting, which is shipping, or directly just specify one shipping over here. And then you want to do is click on package project, which is making the actual build so it can execute your game. So in this case, just click on this, and then you have to choose a location. So go ahead, choose a folder, select the folder, and that will be it. Okay, so you will end up with this Windows folder, okay, which will contain all the things that your game requires and the .exe, which is the most important thing. Now, you cannot just simply give them the .exe. The .exe needs all of these folders and information in order to run. A lot of people might just think that just putting up the .exe will work. No, you have to upload the whole Windows folder. So for making things a bit more accessible, what you have to do is zip it, as I have done here. So you select your Windows folder, right click, and just zip it into a nice folder. Change the name to your game name, and that is what you are going to be uploading to HIOs. But much more convenient to upload a zip file, as you might imagine. So just make the size way smaller and just more compressed, so you can just upload it easier to the HIO, and as actually recommended by HIO themselves. So once you have your build and your package project, what you have to do is go, of course, to the HIO page, create an account or sign in, whatever you need. And now we're gonna go up here into this arrow, and you will see that we have a button to upload a new project. So we would click on this button. As you can see, you would fill everything that you need: your game title, the URL, the tags they will use, your classification if it's a game or whatever it is, the kind of project. Now this is very important. Well, it's not very important, but just informing HIO what type of project is. In this case, if it's downloadable, if it's HTML, whatever. And in this case, we downloadable because you're downloading the zip file with everything, right? And then the release status, the pricing, and then when it comes to the actual important thing, which is uploading the file. So you can see the file size limit is 1 GB. That's why we zip the folder. But if not, you can use the butler thing to upload your game if it's bigger than 1. But that's a whole different thing, which I'm not gonna cover in this tutorial. So just click upload files and you select that zip, and that should be it. Just fill in your stuff, details, genre, tags, blah 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 blah, and then you can just go ahead and set this to public and save and view page. Now, of course, make sure to upload also the cover image and the gameplay trailer and screenshots and whatever you need. With that, you can just create a draft, see if everything is okay, and then just just mark it as public and save it, and your game will be uploaded to itch.io. So that's it for this tutorial. If you found it helpful, I would really appreciate if you could like the video and subscribe to my channel. I have lots of identified tutorials, so check them out. Join my Discord server, follow me on my socials, and now yes, with all that said, bye-bye. So once you have your build, your pet sprite,
Real men don't starve. They do Tai Chi. You want to see?
In this update, we are introducing the class change system directly through interaction with a dedicated NPC. Once you approach the class master, you'll be able to see your current class and choose a new. Specific items and having all the skills from the previous class will be a requirement to advance to the next one. To confirm the change, the NPC guides you through a short dialogue, Then a class transition sequence is triggered with unique VFX and SFX to mark the transformation. This new system adds immersion and flexibility.
Mini Ritz. Perfect for family celebrations.
Hi adventurers, Federico here with another roadmap update. Today, Federico here with another roadmap. Federico here with another roadmap update. Today, we are presenting player-to-player trading. No bots, no auction houses, just old school trade system. Let's dive in. First, approach and aim the player you are willing to trade with. Then, press T to send a trade request. Once accepted, a dual interface opens. All the items displayed in this window are tradable. Gear, mats, consumables. Your loot, your rules. Simply drag and drop the items that you are willing to trade. Both players must press confirm. This keeps the trade safe and intentional. Although the trade system was not included in the pre-alpha roadmap, it's going to be available in the upcoming tests. Share in the comments how do you usually get your items, trading, hunting, or both. Do you wanna see how it all comes together? Join our daily development streams on YouTube.
Are you calling me racist?
That's such a nerve.
Look at this. Just look. If this had been released
Every day, we accumulate more and more data. Notes, PDFs, books, articles, videos, the list can go on and on, contributing to our sense of feeling overwhelmed by information overload. Obsidian is an incredible note-taking software that helps you consolidate all of this data in one place. But this data, these notes, are only useful If you can find them again and surface insights and make connections, the best way to simplify everything to see your notes at a glance is to create a database. Welcome to the new Obsidian Core plugin, Bases, an editable table that lets you filter your notes by properties and connections so you can organize your notes in an easy to understand way. Every day.
You guys are all Nigerians? Oh, no way. Okay. Oh, this is where it gets fun. Because what you don't know about Nigerians is that Nigerians love jokes and they don't have any threshold for what's too far. The most racist shit I ever heard in my whole life is from a Nigerian Uber driver. You get in the car with a Nigerian guy, be like, can you believe these black people? I'm like, whoa, I don't... As a white guy, I'm not equipped. I'm defending black people. I'm like, no, Kendrick Lamar, he speaks to the culture. He's like, shut up, white man. Like, he does fucking... Why are you gay? And Nigeria's got the best names, too. It just sounds like bongos. You know what I mean? It's just fucking, it's... You mean Nigerian, it's like, my name is Ada Bing Bong Bada Bang Joe. You're like, all right, that's interesting. Well, I don't know if we have the time for that, to be honest with you. Like, that's... Y'all got long names, okay? Who's got the longest name, you'll think, of the table? Uluwatomi Singh. That's beautiful. That's not a real name. There's no way. She just said dumb white guy in Hausa. Like, that is a real name? Oh, that's beautiful. It's tricky when cultures have very religious names because you can't say them during sex. It's a fact. It's true. Just fucking hitting it from behind. God is enough to worship. I'll be honest. You guys...
I was curious what life could look like with...
Yo, what text editor do you use? Me? Yeah,
So our objective is to be able to shoot projectiles and get an explosion effect when the projectile hits something, including when we hit the enemy tower and when the enemy tower projectiles hit us. Hello and welcome back. Now let's take a look at our section plan and see how far we've come. Now we know we've created a tank, it can move throughout the world. We made an enemy turret class, we added fire functionality and projectiles, along with health, damage, and destruction in our game. Now we have winning and losing conditions, and we're displaying those with widgets to our HUD. Now the last item is to add our special effects, which means we need some smoke trailing behind our projectile, as well as some explosions and sounds. And there are going to be a couple other things that we add to spice up our game and make it look a bit more polished. Now in this video, we're going to handle some hit particles. These are special effects for when the projectile hits something. This is going to involve something called a particle system. So let's go back into the editor and take a look at the particle systems we have in our project. So I'm here in the editor, I'm going to go into the assets folder and effects, and here we have 3 effects. These are called particle systems. Now we have a hit effect, a death effect, and a projectile trail. Now let's go ahead and double click on P hit effect. And you'll see that here we have a particle system editor. And in this little viewport, we'll see this explosion happening over and over again. Now, trail. Now let's go ahead and double click on P hit effect. And you'll see that here we have a particle system editor. And in this little viewport, we'll see this explosion happening over and over again. Now, luckily, this particle system has already been created for us, and it looks like a nice little explosion. And we would like to see this explosion happen as soon as the projectile hits something, so that is our goal for this video. So here in VS Code, I'd like to go back into our projectile.
Thinking about starting your own business in 2025? Bluehost makes it easy to turn your vision into reality. Head over to bluehost.com and create a professional
Hi guys, I'm Asif Ali and you're watching this job video. Today I created this very simple toonish air explosion in UE5 Niagara, and I just created one and I placed 4 times because it is slightly random every time. So you can see these 4 are slightly random every time, but this is just one particle system. And if you haven't subscribed my YouTube channel yet, please subscribe it. If you like this video, like, share and comment, and let's start this. So let me show you. These are the 4 systems and it has the one system linked here. So this is my effect and it has 4 elements. First is this main core, and second is just some sprites which are streaks initially, then scaling down, and just these dots, sparks. Then I have this flash. This is very bright initially, then it's fade out. Then I have dark particles just to fill this up. So this thing what I did here, you can also do something similar in material also, but in Niagara I'll show you something different how you can do that. Okay, so let me show you. I'll create a new folder here, test, and then I'll create a material M here, and in here I'll just take a texture, that I'll take this blur texture, this one, or maybe this one.
Hello and welcome. In this video, I'm going to be showing you how to make some hanging magical particles. It's a great way to add some depth or mood to your environments and super easy to do. So let's jump into it. I've created this magical glen, which we're going to use as our backdrop. The first thing I'm going to do is jump over here to my folder I've made called FX, which is going to be where I'm creating my Niagara simulation. I'm going to be right clicking in the empty space here, choosing Niagara system, and I want to be creating an empty system. Hit finish, and I'm going to call it NS and Magic Dust. All right, double click that to open it. So I'm going to be right clicking in the empty space here and creating an emitter. And the emitter that I'm going to be starting with is called Hanging Particulates. Once I have that created, go ahead and hit save and minimize and drag this into my environment so I can see it starting to populate. This is looking pretty good actually. However, we're going to modify a few things about it in order for it to fill our environment better. And we're also going to modify the color. So I'm going to come back over here to the Niagara system, and under here where it says shape location under particle spawn, I'm going to widen the box within which it is getting simulated. So I'm going to create it at 1,000 by 1,000 by 1,000. Go ahead and hit save. That's going to make the particles emit over a much larger area and fill our environment a little bit better. Now we can always modify the amount of particles that are populating our scene by coming over here to spawn rate and upping the spawn rate to something like 100. That's going to fill our environment with a lot more particles. Next thing we're going to do is modify the color of these particles to create some golden color to them. I'm going to come to the initialize particle section here, and under color mode, you're going to have a color. In this, I can click on it and choose a more golden look to them. Hit save, and now we have some beautiful glowing golden particles. If they're not glowing enough, we can modify this by adding a new material for them. Open up my Niagara simulation again, come to the sprite render section, and click on this little icon here to bring us to where this default material is located. Now I'm going to take this material and I'm going to drag it into my effects folder and choose copy. I don't want to modify the original particle material itself. I want to modify a copy. So now I have a copy. I'm going to right click on it and call it M_magic dust. Hit enter, and I'm going to double click on that to open it. And what I want to do is add a multiplier into this pipe here that's coming into emissive color. So I'm going to drag off of this lerp node and type in multiply and click on multiply here, connect that up to emissive color. And what I'm going to do is take this and jack it up to 500. This will really depend on your environment, what value works for you, how bright the environment is by default. Okay, that's not giving us enough glow, so I'm going to go ahead and go all the way up to 1,000. Hit save. Okay, now we're going to come back to our Niagara simulation and take our new material, drag it into this material section here, and you should see some much more glowy particles now in your environment. The glowiness themselves is controlled by the bloom, which is located in your post-processing volume, which if you haven't already added one, you should do that. Under the bloom section here, I'm using bloom standard, but you could also use convolution, which is a slightly different, more intensive type of bloom. I'm going to switch it back to standard for now, and you can change the intensity here of the bloom on the particles, which is going to be the glow amount. Lower it. You can also change the threshold here if the bloom is not being picked up by the particles, meaning they're not quite bright enough to reach the threshold at which it starts blooming them. So glowing particles are a combination of the emissive intensity of the particles themselves, as well as the bloom, which is picking up on that emissiveness from the particles and blooming it. And there you have it. This looks pretty good. If you'd like to learn a little bit more about Niagara particle systems and emitters inside of Unreal Engine, and you want
Wix gives you the freedom to tell your story.
Before we start, this YouTube channel created to support people who want to get educated in animation and video games. If you think this channel is worth to support, and if you want to see more educational tutorials on this channel, hit the subscribe button now and don't forget to like this video. Let's get back to the tutorial. And once you download it, create a new folder. Let's go inside the folder and actually here open the material graph. Plane. Ideal gradient exponential node.
Hi guys, I'm Asif Ali and watching this job video. Today we will make this Toonish explosion, and from scratch, step by step, everything, texture, mesh, material, Niagara, everything I will do in this video step by step from scratch. So let's start this tutorial. I don't want this player, delete this, make the light little down so it will be little darker scene. And in the exponent height fog, I'll just make the atmosphere black, and this fog may be just dark gray. Okay, and you can also increase the fog density if you want, and you can also this sphere or maybe just this platonic solid. Yeah, this one is cool. And I'll increase the subdivision maybe this much, and instead of quad I'll take the triangles. And you can make it high poly if you want, but I'll just keep it like this. And then you can use the vertex and with soft selection you can just move these like this, or you can use the sculpting tool like this one and just decrease the sphere, and you can make this, but this is too much, so I'll just increase this, decrease the strength, and like this. So I'm just making it random. Cool. And you can make a different type of shapes, and you can use multiple shapes, but I'll just use one. So this is just to show you how to make. Okay, and UVs, you have to check the UVs. It will work fine, so I'll just select all and normalize it so it will fit. And you can also, if you want, just move these like this. So border is, so I'll just export it, and let's on the desktop I'll call it SM SM. You can call it smoke puff or blob. It's like a blob.
Your team's wasting time asking questions instead of working. With Connect Team, all work communication is in one place. While Dave's on...
So I'll just call it blob. Okay, on desktop I'll save it, and let's make one texture in the Photoshop. So I'll use 1K canvas, and here press D to make it black and white. Then I'll take the noise from here, so I'll just use this crowd, Control S to hide these lines, and then I'll go here and make this little blur, maybe. Okay, canvas, and here press D to make it black and white. Then I'll take the noise from here, so I'll just use this crowd, Control S to hide these lines, and then I'll go here and make this.
So let's go into projectile.h, and I'm going to add a variable to this class, and this is going to be a particle system. Now this can be a private variable, and the type is going to be uParticleSystem, and it's going to be a pointer, and we can call this hitParticles. Now I'm going to forward declare this, and I'm also going to give this a uProperty. So let's say uProperty, and I want to make this edit anywhere, so we can set this from the blueprint for our projectile. And while I'm at it, I'm going to give this a category, and I'll place this in the category combat, since it's sort of related to our other combat variables. Now this is edit anywhere because we plan on setting this from within the blueprint, so we can go ahead and compile this. Now let's hop back in the editor, and I'm going to close out of my other blueprints and go into our actors folder here in blueprints. Actors, here's our BP projectile. Let's open that up and open the full blueprint editor. Now let's take a look in the details panel. Remember, BP projectile self must be selected to see these overall variables. And here's our combat section, and we see hit particles. Now here we have a drop down, and we can select particle systems since this variable is of type uParticleSystem. We're going to use the hit effect for our hit particles. So now we have a variable, and its value is set here in the projectile blueprint. So let's compile and save this. Now the next step is to actually spawn this particle system as soon as we've hit something, which means onHit is the perfect function to do this in. Now we need to know how to spawn particles, and UGameplayStatics has a handy function for that. It's called spawnEmitterAtLocation, and it says plays the specified effect at the given location and rotation, fire and forget. This is nice because we don't have to worry about removing it or deleting it. We just fire off this function, it spawns the particle system and takes care of cleaning it up for us, which is great. So let's take a look at the syntax. Now there are a number of input parameters, but this function has a number of overloads. Now since there are a number of versions of this function, let's go into VS Code and take a look at those different versions. Now I'm going to open up projectile.cpp and take a look at the onHit function. Now just down here at the bottom, I'm going to type UGameplayStatics spawnEmitterAtLocation, and as soon as I type the opening parentheses, its pop-up is showing me the input parameters I need to pass in, but we see one of three, which means there are three different versions of this function, three overloads. I'm going to click the down arrow twice to take a look at this particular overload. Now it takes a world context object, a particle system, and a location, and the remaining input parameters have default values, so they're optional. Notice the rotation parameter is set to 0 rotator. Now if we like, we could set the emitter's rotation to the rotation of the actor by passing in getActorRotation. It's not too important, but I would like to spawn the emitter with the same rotation as the actor, so I'd like to use getActorRotation and pass that in, but the rest of these parameters are optional. So since we know we need to call spawnEmitterAtLocation to play a particle system, we can do this in the onHit function. We know the first parameter is a world context object, and we already know how to handle that. We know that it takes a particle system, and we have a particle system variable that we can pass in. We also know that we need a location and a rotation, and we know how to get those for a given actor using getActorLocation and getActorRotation. So since you have all of this information, I'd like you to use the UGameplayStatics function spawnEmitterAtLocation in the onHit function for the projectile class. So pass in this for the world context object, pass in the particle system itself, that new hitParticles variable we created, and use the projectile's location using getActorLocation, and use the projectile's rotation using getActorRotation. Pause the video and spawn the emitter in the onHit function now. Okay, so I'm going to remove this line that we used just to take a look at the function overloads for this function, and I'm going to place this just before we destroy the actor. So if you placed it, say, at the end of the function, that's okay. The challenge was left open-ended for you, but we're going to place this just before we destroy the actor, because if we destroy the actor, then it doesn't make sense to spawn particles after that. So we're going to do this before we destroy the actor. So we're going to say UGameplayStatics spawnEmitterAtLocation, and first we need our world context object, which is going to be this. Next we need our hit particles, followed by our actor's location, for which we're going to use getActorLocation. Next we're going to pass in the rotation, for which we'll use getActorRotation. And and now we're spawning the emitter at the location. Now, one thing I'd like to point out is that if my owner is a null pointer and we return out of this function early, well, it might be a good idea to just destroy the projectile there. So I'd like to remove this return statement and give this if statement its own body. We'll still return, but just before we return, we should be destroying the actor. So I'm going to call destroy here in this if check. And in fact, even if we fail all of the other checks here, checking the other actor, we don't want a projectile just lingering around in the world, so we should move this second call to destroy outside the if check. That way, we're destroying the projectile when it hits something no matter what. That way, we don't have lingering projectiles for any reason. Okay, and while we're being safe, we should notice that we're using hit particles here, which means we should check to see if the hit particles are set before we attempt to use them. Otherwise, we might be using a hit particles variable that has not been set, and we should not use null pointers. So we're going to place an if check here to see if hit particles is valid. And if it is valid, then it's safe to call spawn emitter at location here. All right, let's go ahead and compile this now. And with a successful compile, we'll hop back into the editor, and here's BP projectile. We have our hit particles set, so make sure that that is set before we test this out, otherwise we won't see anything. And if we hit play, we can wait for our go widget and spawn emitter at location here. All right, and here's BP emitter at location here. All right, let's go ahead and compile. Compile this now. And with a successful compile, we'll hop back into the editor, and here's BP projectile. We have our hit particles set, so make sure that that is set before we test this out, otherwise we won't see anything. And if we hit play, we can wait for our go widget, and then boom, check that out. We have clouds of smoke. We have hit particles being spawned. I'm gonna go ahead and shoot at our enemies, and we'll see that they get spawned when we're hitting the enemies as well. Perfect. So in summary, we now have spawned some hit particles. We have explosions when our projectiles hit something in the world, and the next step is to have a smoke trail that follows behind the projectile as it's flying through the air, and we'll take care of that in the next video. I'll see you soon.
Little blur, maybe offset. Can we'll import that.
Imagine being able to build anything just by thinking about it. Meet Base 44.
So my deck comes with a material. I don't need that. Or you can just rename that. So I'll just, and let me just save all. So basically, what will look issue with it. Then we can do this, but I will add edit. So this is actually, I'll just take the temperature just for now. The blue increase because I will make it freeze. So I will just make a curve, and maybe at point 2 it will be 0, and then starting it is like 3000. Okay, so it's hot and it's dissipating. You can randomize the values, so I don't want hue, I just want value. And then with the help of dynamic parameter I can
app was built on an AI code platform, but no one has published it. Did it ever really exist? Fiverr has the answer. A pool of development experts ready.
So, you just want to add special effects to your animations. Not a problem. Let's say you got an animation, like this one, and you have special effects, like this one, and you want to put them together. First thing you're going to do is right-click on your animation, turn it into an animation montage. Name it, open it, pause the animation, and find out when you want the effects to appear. Then under Notifies, add a new notification, and name it something like Effects. Then right-click, add Notify, and anything made in Unreal 5 should be using a Niagara particle effect. Then go up here, and under Niagara System, pick the name of the effect you're looking for. In my case, it's NS Hit Ground. You're done. Now you can see the particles appear exactly when you said it should. Now from this point you can easily change the position by adjusting the location offset, the rotation with rotation offset, or even change the size with scale. Now let's say that you want the effect to happen in a specific location, like where the hand is. Well, to do that, you can click your skeleton, go to your hand, right click, add a socket, name it, save it, then back under montage, under socket name, set it to the socket you just created. If you don't see it here, it means you forgot to save the socket on the skeleton. But now you should see your effect tethered to your socket. And don't forget, when you're calling these things in blueprints, the variable type is animation montage, not an animation. Other than that, hope that helps, and as always, hope you have a fantastic day, and I'll see you around.
About to get me shredded, huh?
Yes, sir.
About to lose this belly?
Yep.
The way I've come to know you over these past couple months, man, is like you're just a very kind, caring, compassionate human being. You're going to positively influence millions of people.
I haven't thought that far.
Yo.
Yo.
Hey, how's it going?
Hello, right?
Yeah. How you doing?
Are you cognac fired?
No.
This is bad.
No, I wish that's what I was telling you. Yeah.
But I do have really unfortunate news. I hate to be the person to tell you this. No. No.
Hey, I'm saving big with TD Insurance for being a claims-free hybrid driving university grad.
Wow, dude. You should have your own jingle.
Today, let's see how to create stylized smoke in Unreal. This is one of the most useful tricks to know when it comes to visual effects. Knowing how to erode meshes can yield some pretty cool results, especially when trying to recreate stylized effects. So let's see a simplified version. As usual, we made quite a few variations and they are all available on the marketplace and on my Patreon's page too, links below. So without further ado, let's jump right into this. Just wanna say these videos are possible thanks to my patrons, and by supporting me you get access to these projects and many more assets that you can use in your games. So for this one we can begin with an Niagara system directly, an empty one, and rename it to Stylized Smoke, and inside here with right click we can add an empty emitter. This is gonna be for our smoke. This way you see how to set up an emitter from scratch as well. The first thing we need And inside here, with right click, we can add an empty emitter. This is gonna be for our smoke. This way you see how to set up an emitter from scratch as well. The first thing we need is to change the render. We are not gonna emit sprites, we are going to emit a mesh render because we want to emit a specific mesh for this effect that we will show you in a moment how to create. For now, let's get the basic motion of this emitter right. Then what we need is to spawn something, right? So on the emitter update we can add a spawn rate of around 20 and say the lifetime in the initialized particle is random between 1.2 and 1.6. We can already say add a spawn rate because we want to emit a specific mesh for this effect that we will show you in a moment how to create. For now, let's get the basic motion of this emitter right. Then what we need is to spawn something, right? So on the emitter update we can add a spawn rate of around 20 and say the lifetime in the initialized particle is random between 1.2 and 1.6. We can already say that the scale is going to be something between 1 and 2. We will see later on if that's okay. Okay, let's just add a shape location so they don't all spawn in the same. Position. It can be a cylinder with no height but with a radius of 20. Small thing. Finally, some motion. With add velocity. This gives us a warning. Essentially saying that we are missing the solve forces in velocity, and we can click fix issue and Unreal will automatically add it. Oh, let's say the velocity is in code around 800, and if we want this to go up we can say the code cone axis is 0, 0 for the X and Y and 1 for the Z, and then you can play a little bit with the cone angle so it spreads. This is what we got, as you can see. Some basic axis 3D models, but the motion is more or less there. Now let's take care of the aspect of this and let's create a very basic mesh. We are gonna use Blender because it's easy to pick up and it's free, and I'm gonna guide you the best face. A couple of as a pixel select size value, increase the poly, the sure that everything is inside these boundaries, this square. we can scale it down with S, select the vertex that are outside the boundaries with B and push them inside with G. They won't be perfect, but they're acceptable UVs for this effect. Now let's rename this to Smoke01 and let's export this in File, Export and select FBX. Turn on selected objects so we only export these, rename it to SEM_smoke, and in our case we are going to export this directly to the Unreal project. As soon as we switch over to Unreal, it has detected that there's a new file, it asks us if we want to import, and we can say import all. Close this window, and now let's assign this right here so you can see something, and here we go. That's the beginning. Looks very interesting already. Now let's make sure that it has some random rotation by adding the initial mesh orientation module to the particle spawn. Make sure mesh orientation mode is set to random, and finally we can control the scale of this with the scale mesh size on the particle plate. Let's transform this into a float and then transform it to a curve, and we want this to with the scale mesh size on the particle plate. Let's transform this into a float and then transform it to a and finally we can control the scale of this with the scale mesh size on the particle plate. Let's transform this into a float and then transform it to a curve, and we want this to essentially grow. So the first key is going to be 0.1 more or less, and the last key 1.5 for example. I'm going to use auto curve, and we want this to essentially grow. So the first key is going to be 0.1 more or less, and the last key 1.5 for example. I'm going to use auto so it's a little bit smoother, and fix the handles so we can have this curve right here. And this 1 more or less, and the last key 1.5 for example. I'm going to use auto so it's a little bit smoother, and fix the handles so we can have this curve right here. And this is what we get at this point. Right, so we need to take care of the aspect of this. Let's go ahead and create a material. With right click, material, I'm gonna call it the M_smoke. Double click to open it up, and on the details let's already switch the material to masked so we can essentially erode this. And that's the foundation on how we made all of these effects, which are all available on the marketplace, by the way. Now we essentially need a texture to erode this according to that texture. So let's search for a parameter 2D, call it the main text, and to erode that texture we can connect the RGB to a power node. Now, if we want the colors of Niagara to influence this material, we need the particle color node, multiply it with the power, and connect it to the emissive color. Now there's one thing we need, which is to control that power value, how much we dissolve the main texture, through Niagara. For that, we use a dynamic parameter node. It comes with 4 parameters. We can rename the first one to erosion and the second one to power. And the default values could be 20 and 0. We can connect the power to the power node, and the erosion parameter is a cool trick that we can multiply with the R channel of the main texture and then connect to the opacity mask. This is what will erode. The power is to dissolve the texture. In combination you can create very interesting effects. I'm just gonna assign the Voronoi to the main texture, which by the way it's available for free on the link below, and this is what we have. Lastly, if you guys want to control the metallic and specular values, you can create a scalar parameter. I'm gonna call it the use auto, so it's a little bit smoother, and fix the handles so we can have this curve right here. And this is what we get at this point. Right, so we need to take care of the aspect of this. Let's go ahead and create a material. With right click, material, I'm gonna call it the M_smoke, double click to open it up, and on the details let's already switch the material to masked so we can essentially erode this. And that's the foundation on how we made all of these effects, which are all available on the market. Call it the main text, and to erode that, to erode this according to that text. So let's search for a parameter 2D, call it the main text, and to erode that texture, we can connect the RGB to a power node. Now, if we want the colors of Niagara to influence this material, we need the particle color node, multiply it with the power, and connect it to the emissive color. Now there's one thing we need, which is to control that power value, how much we dissolve the main texture, through Niagara. For that, we use a dynamic parameter node. It comes with 4 parameters. We can rename the first one to erosion and the second one to power, and the default values could be 20 and 0. We can connect the power to the power node, and the erosion parameter is a cool trick that we can multiply with the R channel of the main texture and then connect to the opacity mask. The values could be 20 and 0. We can connect the power to the power node, and the erosion parameter is a cool trick that we can multiply with the R channel of the main texture and then connect to the opacity mask. This is what will erode. The power is to dissolve the texture. In combination you can create very interesting effects. I'm just gonna assign the Voronoi to the main texture, which by the way it's available for free on the link below, and this is what we have. Lastly, if you guys want to control the metallic and specular values, you can create a scalar parameter for the metallic and for the specular, with default values of 0 and 0.1 respectively. Let's save the scalar we have. Lastly, if you guys want to control the metallic and specular, you can create very interesting effects. I'm just gonna assign the Voronoi to the main texture, which by the way it's available for free on the link below, and this is what we have. Lastly, if you guys want to control the metallic and specular values, you can create a scalar parameter for the metallic and for the specular, with default values of 0 and 0.1 respectively. Let's save these, and as a good practice, let's create a material instance out of this original material. I'm gonna drag it outside of the originals. It's just good practice. Let's go back to our Niagara system, and on the mesh renderer, let's original material for the metallic and for the specular, with default values of 0 and 0.1 respectively. Let's save these, and as a good practice, let's create a material instance out of this original material. I'm gonna drag it outside of the originals. It's just good practice. Let's go back to our Niagara system, and on the mesh render, let's enable material overrides, add a new material override, and well, assign the material instance of the smoke, and here we go. It's a begin. Let's go back to our Niagara system, and on the mesh render, let's enable material overrides, add a new material override, and well, assign the material instance of the smoke, and here we go. It's a beginning. Now add a new material override, and well, assign the material instance of the smoke, and here we go. It's a beginning. Now the cool trick is to animate the erosion, and if you want to animate something, it needs to be in the particle plate, where we can use the dynamic material parameters, so we can access those values that we have exposed on the material. And as you can see, Niagara, immediately that we want to animate something, it needs to be in the particle plate, where we can use the dynamic material parameters, so we can access those values that we have exposed on the material. And as you can see, Niagara immediately detects that there is an erosion and a power parameter. For the erosion, let's convert this float to a curve, and the way this works is, well, in the beginning, let's say the first key starts at 0.3 and it has a value of 15, and last key we can leave it as it is. Let's select everything and say it's auto. It's at 0.3 and it has a value of 15. And last key we can leave it as it is. Let's select everything and say it's auto, so we can have these handles and create this curve right here. Here, what will happen is that 15 needs no erosion and 0 is completely eroded. So in the beginning we don't have erosion, and at the end, well, it's eroded, creating this cool effect. And now you can do all type of things. For example, let's use a scale color, say it's RGBA together, and convert this to a curve, and it will create a gradient. Say it's RGBA together and convert this to a curve, and it will create a gradient. And the cool thing is that we can push the last key more or less to around here, as well as the first key to around 0.25, add a key in the middle. You can say it has this value in terms of gray, and for the last key, a very close dark, and we create this very cool stylized smoke of gray. And for the last key, a very close dark, and we create this very cool stylized smoke. Just look how awesome it is. And now if you want to control these as if it was a wind, you can add a wind force in the particle update. We get a warning saying that there's a few models that are missing, like the drag module. We can click fix issue. There's another warning on the drag saying that it needs the drag to be before solve forces and velocity. You can click fix issue and Niagara automatically fix this, which is awesome. And now, well, on the wind speed we could say something like 1500 for the X and for the Z as well. and we prefer to disable turbulence. We get a more realistic feeling, and this is what we get. So as you can see, you can control the wind force, you can play with this, and it's super cool the effect we can get with just the erosion. Now it would be super awesome if you guys could support us on Patreon, where you can get all of these effects from this pack and many more assets that you can use. That would be awesome, and we would appreciate a lot if you guys could support us. This is also available on the marketplace, by the way. I want to say thank you to each patron that supported last month, and a quick shout out goes to Welcome back, guys. Today let's see how this chain lightning can be done in Unity.
Dude, if you hate your job so much that you have to dissociate, it might be time to set up your online business on Stan.
Today, let's see how a good muzzle flash can be done in Unreal. I'm going to show you the whole process from setting up Niagara, creating the meshes, and drawing a quick texture too. And we are going to specifically see this one, which is one of the many I have available on the marketplace or on my Patreon page. There's 2 volumes with more than 50 muzzles. So yeah, a lot.
goal for this video is to have smoke trails attached to our projectile and following it as it flies throughout the world, and this will make our projectiles look quite a bit cooler. Hey, welcome back. So we have hit particles, but now we'd like a particle system to follow behind the projectile as it flies throughout the world. So let's talk about how we're going to do this. Now for this particle system, we're going to add a component to the projectile class. Now we've already added a variable called hit particles, and its type is uParticleSystemPointer. Now this is not a component. It's simply a uParticleSystem that we use when we call spawnEmitterAtLocation. So spawnEmitterAtLocation does the creation for us dynamically at runtime in the onHit function. But for a smoke trail, we're going to use something called a particle system component. The particle system component is an actual component that we're going to create in the projectile's constructor using createDefaultSubObject, and we're going to attach this to the root component so that it can follow the projectile around. Now the uParticleSystem component has a variable called template. This is something that we set in the blueprint. Remember when we had static mesh components? And in the blueprint, in the details panel, for the static mesh component, there was a variable called static mesh, and that had a dropdown allowing us to set the static mesh for that static mesh component. The particle system component has a similar variable. It's called template, and this will allow us to use a dropdown to set the particle system for this particle system component. So you already have experience creating components. This process is no different. So this will be your challenge. You're going to add a uParticleSystemComponent pointer variable to the projectile class. Make it visible anywhere, so we'll have access to its properties in the blueprint. Create this in the projectile constructor, which means you're going to use createDefaultSubObject, choosing the correct type and including the correct header. I'm going to leave it up to you to search the documentation for the include for the uParticleSystemComponent type. Once you've created it, attach it to the root component. We've already seen how to attach components to other components. Now go ahead and compile your code and open the blueprint editor, and in the projectile blueprint, select our new particle system component, and in the details panel, set the template using the dropdown, and you're going to choose the p_projectile trail as projectile.h, and here is where I'm going to add the particle system component. Now I'm going to forward declare this, and it's going to be uParticle system component pointer, and I'm going to call this trail particles, since this will be and make it visible anywhere, as is done with our components typically, and I'm going to give this a category. And I'll add this to the combat category. So we have a uParticle system component pointer. It's time to construct this in the constructor. So let's go to projectile.cpp and scroll up to the constructor, and we can add this here. So we're going to say trail particles and use create default subobject using uParticle system component. And in the parentheses, I will give it some text and call this smoke trail. Now I'm going to need the include for uParticle system component. So I have my documentation. I'm simply going to search for uParticle system component and click on uParticle system component, scroll down, and here's the include. It's in particles/particle system component.h. So I'm going to include that here at the top, just under gameplay statics. I now need to attach this to rootcles and with BP projectile, and here is my trail particles, and it's parented to projectile mesh, which is the root. So I'm going to select trail particles, and here in the details panel, I see the template variable. It's under particles. I can select the dropdown and choose projectile trail. So that will set our projectile trail particle system. And if you were curious what projectile trail looks like, we can go back to assets, effects, and double click projectile trail. We took a look at this early on in the section, and we saw that this is what it looks like. So this is the particle system that will be attached to the root component. And as you'll notice, it's designed to keep looping. So it's going to keep playing as long as it exists in the world. So let's go ahead and test this out. I'm going to go ahead and hit play, and as soon as I can, I'm going to shoot some projectiles, and check that out. This looks amazing. Our projectiles now have a smoke trail, and if we go and aggro the enemies here, we'll see that their projectiles have smoke trails as well. Perfect. So in summary, we now have smoke trails, and our projectiles look quite a bit better. Now we still need a few effects, and we're going to take care of those in the videos to come. I'll see you soon. Okay, so we'd like to see an explosion when one of the pawns dies. So if I destroy a tower here, there's the explosion, and if the tower destroys me, I can, boom, blow up. Welcome back. Now we've been implementing some special effects, and the next special effect we'd like to implement are some hit particles that will cause an explosion on death. This means death for the tower or death for the tank. So since this will be implemented for each pawn, inheritance should come to mind. So for these death particles, let's form a game plan. First, we need to add a uParticle system pointer, and we're going to add this to the projectiles now have as long as it exists in the world. On in the section, and we saw that this is what it looks like. So this is the particle system mesh, which is the root. So I'm going to select trail particles, and here in the details panel, I see the template variable. It's under particles. I can select the dropdown and choose projectile trail. So that will set our projectile trail particle system. smoke trail, and if we go and aggro the enemies here, we'll see that their projectiles have smoke trails as well. Perfect. So in summary, we now have smoke trails, and our projectiles look quite a bit better. Now we still need a few effects, and we're going to take care of those in the videos to come. I'll see you soon. To the base pawn class, because we'd like the explosion effect to happen when either the tank or the tower gets destroyed. Next, we're going to spawn an emitter on death. Now the base pawn class has its own version of handle destruction, and that's called in both the tank and the tower using super. So because this is implemented in base pawn, whatever we put in this function in base pawn will happen for the tank and the tower. So we know how to spawn emitters at location using new gameplay statics, so that should be pretty easy. Now the last thing will be to set the particle system in blueprints, and we have a p_death effect. particle system that we can set this to, which means our particle system pointer needs to be exposed with uProperty and set to be editable, whether it's edit anywhere or edit defaults only. And these are all things that you have experience doing, so this is going to be your challenge. Add the particle system variable. Add this to base pawn because we want to inherit this functionality in the tank and the tower. Next, spawn the emitter. We saw that handle destruction in the base pawn class is the perfect place to do this. And next, you're going to set the particle system in blueprints since you're going to make this particle system variable exposed to the blueprint editor. So pause the video and implement death particles on your own now. Okay, so let's go into the base pawn header file, and we can add a new particle system variable. This is going to be private, and it's going to be forward declared, and the type will be U particle system pointer, and I'm going to call this death particles. Now we need to expose this so we can set it from the blueprint editor, so I'm going to make this a U property, edit anywhere, category, and I'm just going to place this in combat. There we go. So now we're going to have a particle system, and we need to spawn this in handle destruction. So let's go to basepawn.cpp and find handle destruction. And here it is. We even have a to-do here that says visual and sound effects. So we're taking care of visual effects.
I'm saving big with TD Insurance for being a claims-free hybrid driving university grad.
Love it.
And I
You
remember
should
just from doing this so
Hello
much
everyone,
that it's
my name is
in
Reza and welcome to my channel. Quite recently I have received lots of requests about Niagara, the VFX system within Unreal Engine, and why I'm not covering this topic as part of my Unreal Engine series. So I made a decision to record a number of videos on this topic to be able to thoroughly showcase the engine's capabilities. I start by breaking down this topic into smaller digestible chunks and covering the basics of Niagara first and how to read stages, modules and properties, and we gradually but surely build on top of this lesson in future recordings. So if you have not had a chance to work with Niagara, I highly encourage you to start from this very specific video, so everything that we cover after this will make sense. We have a lot to cover, so let's dive right in. I'm going to start by creating a brand new scene. I can go with blank. It's okay to enable ray tracing and starter content we really don't need. I'm going to call the project Niagara and we are going to create the project. Alright, here I am in a brand new scene. You may be wondering, where should we start with this? Do we have any buttons or do we have any menus? Well, you can actually start with a blank brand new scene. That's no problem at all. There is no mode or menu set that you need to be in. You can start with any level at any point of time. First things first, I'm just going to right click and I'm going to create a folder under my name, Reza, and then within that I am going to create a Niagara folder so I can put all of my emitters and systems in here. Now let's start our very first Niagara emitter. So that's the very first component that you need to know about in order to start with the whole process. I can just simply right click and go to Effects, and here I have the Niagara emitter. I'm going to click and I have 3 options. Create an emitter and using certain templates to start with, which is certainly a less intimidating way of learning this system. The second one is copy an existing emitter from your project into your brand new project, which is something that we don't want to do. And the third one is to create an empty emitter. Now, while this doesn't provide you with the result right off the bat, from experience, I noticed that it's actually the best way to learn Niagara, because it actually shows you all the building blocks, the foundation or the skeleton of the system without having extra modules and auxiliary nodes to confuse you. So, create an empty emitter seems like a reasonable start. I'm going to go ahead and finish. Now it's time to rename our Niagara emitter, NE for Niagara emitter, and I'm going to call this my first emitter. Very typical way of naming, of course. I'm going to double click and that takes me to the emitter editor. That's where I actually get to see the emitter itself, the properties, the timeline, the viewport, and some extra parameters that I can add or remove to this emitter. First things first, how to navigate. Right mouse button hold is going to pan. Left mouse button is going to select components, and scroll is going to zoom back and zoom in all the way to 1:1 ratio. Now to zoom in even further, which actually I found useful, is to hold down Control and start scrolling, and then you can see I'm getting more zooms in all the way to 7. So remember, you can always zoom back, zoom in, it stops from 1:1, zoom back, and this regardless of how far you would like to zoom on this emitter editor. So that's quite nice. I can just zoom in and click on this toggle comment to hide it. We have timeline, which shows you how long your emitter is going to be active for, and right now it's blue, and every time you see the blue color it means infinity, and the system is controlling it. So the loop situation is controlled by the system, that's why it's blue. You've got the timeline head, and you've got the name of the emitter, and you've got your timeline control, so you can move one frame to the next, to the back. If you have keyframes, you can toggle between keyframes, you can set in and out, you can set it to loop for your playback range, so on and so forth. You have F-curve in the next tab, so you can just look at the function curves that you're going to create within the properties channel. I will talk about that. And then you've got less to some degree important tabs, script stats, and Niagara log just to be able to troubleshoot a little bit and see what exactly is going wrong. So sometimes these tabs are actually very, very important, but you know, at least in a very basic level, when we're creating one emitter, chances are you won't be using those two tabs as often. I'm going to stay within this timeline tab, and let's talk about the components of this emitter. First things first, we have stage and CPU. CPU, obviously, if I click on it, and you can see it here, so can probably give myself more room so we see what exactly is happening. So at the moment, any particles that you create, your CPU is in charge of simulating it. In the future lessons, very soon, we will talk about the benefits of using GPU instead, and what would be the difference between CPU and GPU, how to toggle it, and how to remove any errors or warnings that you may be getting. And then we've got stages. Now, stage is going to add a new stage into this list. So right now, we already have well-defined stages or groups. We have emitter spawn, emitter upgrade, particle spawn, particle update, and render. I can totally go in and add a stage to this structure. So let's say I can create an event handler. So one particle does something and that triggers a behavior for another emitter. And these are the ways that you can actually link one emitter to the other emitter. We will talk about that in future lessons. Obviously, it's way too early to talk about stage. So another thing to be mindful of is you always need to read it from top to bottom. So we create the emitter, and this emitter is going to have certain behaviors, and based on those behaviors, this emitter is going to create particles, and this particle is going to have certain behaviors that we need to tweak. For example, with emitter spawn, there is really not much that we can add at the beginning, because, well, spawn means let's get this created. So at creation, what exactly you want to do. So with emitter, chances are we're not going to make so many decisions, so rarely used, to be honest with you. With emitter update, let's say number of particles is something that we sometimes want to understand. So are we going to use 10 particles or 2000 particles? And this is something that we are going to specify. With particle spawn, it's going to be, again, at creation, what's going to happen when you would like to, when the particles get created, what sort of initial size we're talking about, what location, what color, what would be the lifespan or life cycle of the particles. And once that gets created, we're talking about particle update. And every time you see update, emitter update, particle update, it's after creation, where we're dealing with number of frames. A good example for particle update would be changing an attribute over time. Let's say changing the opacity over time, or translating an emitter over time, and that's something that we can specify within this particle update. So hopefully this makes sense. Let's go to the next chapter and start adding modules within this emitter node right here. Now, while we have these groups already lined up, by default, they're not really doing anything. They're all empty because there is no modules assigned to it. And think of modules as sort of elements responsible for making things happen. So without modules within these groups, you pretty much don't have anything. You have an empty emitter. And that's why in the display, we actually do not see anything. It's pretty much empty. So the first module that I tend to add within emitter update is emitter state. And the way that you add module is by clicking on this plus You get certain suggestions, and these are most commonly used modules, and then you get a full list of all the modules that you can apply to this particular stage or to this particular group. So I usually start, if I type in state, with the emitter state. Now emitter state sets the expectations for the emitter. It gives you the life cycle of the emitter. You can totally start without it, but chances are that if you add different modules, they will error out and ask for dependencies. And one of the key dependencies is, all right, you would like to have an emitter for how long? So let's sort of make that an automated process. Before we add any modules, let's just throw in an emitter state so we know this goes for how long. And as soon as I do that, you can see part of this blue infinite bar is now a tiny life cycle, which is more like a suggestion, because right now life cycle mode is set to system. So the system still goes through infinity, but if you would like to change it, it goes from 0 to 240 frames. So you can actually see everything inside this module. You can select to see only life cycle or to see only scalability. I'm going to go to life cycle and I say, you know what? I would like to take charge of the life cycle. So I don't want the system to make decisions for me. I would like to do it. So self should be selected. Now within that, you can still go for infinite to say, all right, we are not going to deactivate that anytime soon. Or you can say, you know what, loop that only once, loop duration is fixed, and the duration mode is fixed, and the duration should be more than 1. And look what happens to this green bar once I change this one to 5. So you can see it goes to 5 seconds. And look what happens if I get the handle and try to move it. I can probably zoom in and look at this area right here. If I start tweaking this, you can see loop duration does change. I'm going to reset that one to the original value of 5 and select our module so we don't see extra information in there. So you can see now self is selected, and once is selected for my loop behavior. Obviously you can set it to multiple, right, and have that loop go on multiple times, but for now I can just set that one to once. Excellent. I'm going to clear up my filtering right here, and that's how you add a module into a group within your emitter. Let's go to the next chapter.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44.
Now we know how to add a module. Let's add more modules and come up with a particle system, or at least a particle in our viewport. All right, so the next module that I would like to add, if I click on the emitter update, is this spawn burst instantaneous. So I'm just going to go ahead and click on that, and just like that I'm creating a stack. So the reason we call that a stack is because modules are processed sequentially from top to bottom. So while I'm making that stack, you always need to remind yourself that the one at the bottom overwrites any common attribute from the one underneath, if there is any overlapping attributes. And whatever you do, the first building block is the first one that you're creating. At any point of time, you can go in here and rearrange, and you can see as soon as I rearrange, then I'm changing this stack, and that may not work well within my emitter system. As a matter of fact, if I just go ahead and press delete on the emitter state to just have spawn burst instantaneous, I'm getting an error saying that the system and pick self and go to infinite and pick once, and we just leave it at that. You can go and change the leave duration to, or a loop duration, excuse me, to whatever you want to have. It really, there's no right and wrong here at this stage. We're just testing. So I'm in the same location. Now you may say, Reza, what is happening? Why I'm not seeing anything in here? Because we have an emitter. Maybe we should sort of create a particle. Yes and no. Before we get into particle spawn and particle update, let's talk about render actually. And render defines how the output will get displayed. We have different types of render types, or the way that you see the particle. We have sprite, we have mesh, we have ribbon, we have light, we have geometry cache. As a matter of fact, if I click on this plus to add a new renderer, you can see that we have sprite, ribbon, mesh, light, geometry cache, decal, and component. Now the most common one is a sprite, and the cheapest one is sprite. Why? Because it actually gives you this, and you may say, yay, we've got a particle. This is not a volumetric particle, although I can just move around and basically see the particle, and looks like it's a 3D object. In fact, that is not the case. It's just a 2D sort of camera-faced plane. So just like any sprites in other software packages like Maya, it's just a 2D plane with a material assigned to it. If I click on reset the default, you can see all I have all of a sudden is a plane that has been aim constrained to the camera. I can press Control Z, and if you would like to take a peek at this material, you can always go into Browse to find default sprite material. You can just minimize it right here. You can see the Unreal Engine found this material for us. It's under Niagara content, under plugin, under engine content. So if I scroll all the way up, you can see it's under plugins and it's under engine content. So if you would like to see it, make sure that your show engine content and show plugin is enabled, so you kind of get to it and you can see it. But this would be the trick later on to create simple effects. We use sprite. We, let's say, attach a puff of smoke as a material, and we multiplied them, scattered them, and direct the movement of them using force field, and we get to create simple effects. And it's, yes, that easy. So now we have this. Let's go into particle spawn and particle update and see what else we can add to create particle and eventually move them. All right. With particle spawn, it gives us the opportunity to specify important attributes, including the size of this particle, because in the emitter, we can just have control over the length and how many particles, basically the rate, but no attributes to control the size. And that gets created or controlled through a module that we add under particle spawn. So if I click here, you can see we've got some basic ones. I again tend to start with initialize particles. So if I type in, you can see initialize under initialization, initialize particle is there. And that initializes common attributes. Again, it sets the standard for the particle system that you're about to create. Lifetime mode, and you can just set that to random or a set value. And remember, this is the life cycle for your particle. Don't confuse that with the life cycle for your emitter. So if you have a life cycle for your emitter, as soon as this life cycle ends, everything will vanish. But if the particle gets a life cycle, this particular particle may vanish, but the one right next to it may still be alive, especially if you have a random situation where you say one lives for 1 second, the other one lives for 2 seconds. So don't confuse the two. You have color, but I have way better methods to assign color to our particles, so I'm not going to talk about that. So we have, again, control over the sprite size, sprite rotation, and sprite UVs. And you probably now know why I talked about sprite renderer now, because we've got mesh attribute and ribbon attribute. And if you remember, we had ribbon and mesh renderer. So technically speaking, we are not going to talk about this if you have sprite set as our renderer. Another way of doing this, instead of looking at all of these and feel overwhelmed, you can go and click on these tabs and go through the whole thing one by one. Again, at least for this lesson, we're not going to talk about these two. Definitely in future videos, we have to go and explore these two options. With point, let's set the lifetime and let's set the sprite size. At the moment, it's unset. You can make it uniform, random, non-uniform. Let's say I'm going to go with uniform, and all of a sudden we've got a smaller particle. I'm just going to set that one to 20, 30, and keep looking at this area right here. You can see how the particle gets bigger and bigger and bigger. Rotation mode, very useful, especially the random one when you have a texture instead of this solid color, because then you don't want every single texture to look exactly the same and face the same orientation. You want to sort of rotate it around. So right now it may not make sense, but eventually it does. And if I go back to point, I set the lifetime to 1. Probably I'm going to just increase it to 2. And that should do it for this particular example. So initial particle, quite useful. Now I'm in particle update. The first one, just like emitter update, is the state. So I would like to go in here and type in state, and I would like to add particle state. And the good thing about particle state is it just, if I ever so slightly go in here, it kills particles when lifetime has elapsed. So to tell you the truth, is one of the most important modules that you need to add so you don't run out of memory. So it automatically kills the particles when lifetime is finished. Perfect. What else can we add? Let's add one of the modules that actually makes things a little bit fun. So scale color is what I like to add every now and then if the situation calls for it. And that gives you control over changing RGB and changing alpha, in this case opacity. So I can go in there and change this number 1, which is solid or opaque, to 0.5 to 0.1, and you can see it's gradually but surely fade. But wouldn't that be nice to sort of have that over time instead of just one fixed value or absolute value throughout these 5 seconds? I'm going to go and click on this arrow right here to have access to some suggestions here. One of these suggestions says float from curve. So what it does, and you see that in Niagara a lot, and we use it a lot, it looks at a value and it converts it to a function curve that you can tweak over time and add interactivity. So instead of adding manual keyframes to frame 0 all the way to frame 240, you just convert it to an F curve, and you can just change the F curve over time so it plays around with the value over time, just like a, let's say, a graph editor inside Autodesk Maya, if you are familiar with that application. So float to curve, And look what happens. It gives us in frame 0 a value of 1. And as I move forward, look at the, if you're not sure if you can read the tooltip, it goes from 0 to 0.5, 0.3, 0.2, and when I reach 1, the value is 0, and 1 is pretty much the end of my particle cycle. So if I play, you can see how it vanishes. 1 opaque to 0, 1 to 0. So you can see how useful this can be to add interactivity and finer control over what you do. If it's hard to see this window, you can always click and show this curve in Curve Editor right here. So I can actually even move it up and plug it somewhere else, let's say here, or I can just move it to my second monitor if need be. At the moment, I'm going to leave it here. You can add and fine-tune this curve by middle mousing to add a keyframe, right? So a lot can be done. I'm going to undo because I really don't want to mess this up, but a lot can be done. You can select each keyframe, right click on it, and change the interpolation. For example, I can select this one and press 1 on the keyboard and get a tangent to play around with how quickly this transition, whatever transition I have, is going to happen. So having that F curve using float to curve will add lots of possibilities and flexibilities to my particle update. All right, I think it's a good time to talk about Niagara system. So basically, if I try to put my emitter onto this level, I simply can't, because it needs to be encapsulated within a Niagara system. And that Niagara system is like a container that you can store one or multiple Niagara emitters inside it. Now you have two ways of doing this. One is to create a clean Niagara system and create a clean Niagara emitter inside it. The other way is to use the existing Niagara emitter and place it inside a brand new Niagara system. Let's explore both. Let's do a clean Niagara system with just a template Niagara emitter. And that's very easy. You just right click, you go to Niagara system to create a brand new Niagara system. You can do it through Effects, Niagara system, or you can access Add button, Niagara system here, and from Effects, Niagara system. And in here you can just create a new system with emitter templates. I'm just going to go New, and in here you can choose a preset. I'm just going to pick a simple sprite burst, which is very similar to what we've been creating so far. But right now there is no emitter. You have to either click on this green plus button, well, green rectangle with white plus button, or you need to double click on it to create the emitter, and only then you go finish. You can see the icon is slightly different, saying that, all right, it's more like a container, have more of these stars icon in it. If I double click, you can see I am inside the Niagara system right now, which is, the layout is kind of similar. So you're still dealing with parameters on the bottom left, the display or preview window on the top left. I've got my timeline and curve editor on my bottom center, the Niagara system overview window right in the middle, and the parameters and properties window on my right hand side. So that's the sort of a typical window. You're still, if I double click, then you go, well, which is very similar to next Niagara system. And in here you can just create a new system with emitter templates. I'm just going to go New, And in here you can choose a preset. I'm just going to pick a simple sprite burst, which is very similar to what we've been creating so far. But right now there is no emitter. You have to either click on this green plus button, well, green rectangle with white plus button, or you need to double click on it to create the emitter, and only then you go finish. You can see the icon is slightly different, saying that, all right, it's more like a container, have more of these stars icon in it. If I double click, you can see I am inside the Niagara system right now, which is, the layout is kind of similar. So you're still dealing with parameters on the bottom left, the display or preview window on the top left. I've got my timeline and curve editor on my bottom center, the Niagara system overview window right in the middle, and the parameters and properties window on my right hand side. So that's the sort of a typical layout that we're dealing with Niagara. But I have the preset that I've made, which you can see it's very similar to what we created so far in this lesson, and a Niagara system with state already added. And remember, that's something that we did. We created emitter state, we created particle state, and I mentioned that it's one of those modules that we tend to add. It needs to know its life cycle, and you can see the life cycle is right here at the moment. So I'm just going to pause this so it won't run forever. But that's how you create a container, and that container holds something. But what if I want to use my existing particle here and add it to this system? Because if I go to content drawer and try to drag and drop it and include my existing emitter into my new system, I simply can't. You have two options. You can convert your emitter inside your content drawer and create a brand new system, or you can use your existing system. I'm going to just delete this one and bring your emitter here using the letter E. So I'm here, I'm pressing the letter E, and it says add emitter. Well, all it takes is for you to search for your Niagara emitter. If I just do that, it's not going to bring anything because it says library only. I'm going to turn it off. I'm just going to say that, all right, this is my emitter, and I'm going to go to parent emitters, not the templates, and there I have my first emitter. So that's one way of bringing your emitter into a clean system. Or if I don't want to do it this way, I can just go in there, select my emitter, and right click on it, and it says I'm going to create a brand new Niagara system, and I'm going to put your emitter that you're selecting right now in it. So I'm going to create a second Niagara system. Now I don't know which one I created. There you go, that's the one. And it inherits the name, puts my Niagara emitter that I've selected inside that system. So I'm just going to get rid of the empty one because I believe I already put my Niagara emitter inside a system, and now I should be able to drag and drop my Niagara system inside the emitter with no problem at all. Right now the gizmo doesn't allow me to see the single particle that I've made, so I can easily go in there and say game view, and you can see the particle does show up. All right, let's go to the next module and push the pedal a little bit. Let's get a little bit faster, add a few more modules inside my emitter, and come up with something interesting. All right, let's go ahead and add a little bit of interactivity to our simple sprite burst. First things first, I have problem with this burst instantaneous because it's really difficult to separate those particles. They get created at the same time and die at the same time. Not the most exciting module. I can easily replace that with something very similar, and it's called spawn rate, which does kind of the same thing, but with this you can actually specify number of particles. And what I can do with this one is I can just simply disable the module. You can totally select it and press delete on it. Non-destructive approach is to just disable it, and if you want to go back to it, you don't need to recreate it later on. So with this spawn rate, a number of particles, let's say I just want 50 particles. Another issue is the emitter dies really soon, because remember we set the emitter life cycle to just live only once for 2 seconds, which is quite short. So what I can do is to go to loop behavior and set that to infinite. And of course, another method is just to go to life cycle mode and set that to system. I tend to keep that to self and just go with infinite. With that, I can just toggle between infinite, loop, and multiple number of loops. All right, we're making progress. Now, how can we move it? Well, you have two ways of moving a particle. One is to add initial velocity into a particular axis or multiple axes, or you can use force field. Let's start with the easy one, which is add velocity. Now, think about it, where we should add the velocity force. If we put this under update for emitter, emitter generates particle, and that's it, really. So there is no space or room for velocity. As a matter of fact, there's a much easier test. If I just type in velocity, nothing comes up saying that, all right, velocity doesn't get applied to an emitter. Velocity is something that you apply to particle. You can do it at creation, you can do it during its life cycle. We're going to do it at creation. So you can see even in the suggested list of modules, add velocity is the first one, because it's a very common module to add to simply move your particles. If I go add velocity, it comes up with as an error saying that, all right, I need a post dependency just to be able to calculate the velocity, because yes, you added the velocity and you are going to set a buoyancy, so on and so forth, but how will I be able to calculate it? To do that, you need to add an important node after creating the particles. So particle update would be the right space for it, because we're going to do it during its life cycle. Just type in solve, and it says solve your velocity and all of your forces. As soon as you add that, the warning goes away, and you can see that the particles are now going crazy. And they've got different sizes, because in initial particle, I set the sprite size to random. You can do uniform, which is kind of boring, and you can do random, 5 minimum, 10 unit maximum. You can just play around even further to break up the sort of boring look. Now you may say, Reza, why it's so straight? It's coming from the velocity itself. We have velocity mode set to linear, straight line. You can emit from point, which is like omni. If I click, you can see we get those particles distributed in all directions from a point, hence from point. You can do it in a cone. So it's more like a directional emitter where you get a cone angle and you get cone axis. So we've got cone axis and cone angle. Right now it's emitting towards X, positive X. We can say don't, just emit towards Z, which is up axis. You can play around with inner cone angle, with the actual cone angle. So we can say widen the cone. So you sort of change the spread to 80 degrees, or make the cone quite tight, which is like 15 degrees, almost a straight line. So that's the opportunity that you have to play around with this. Of course, at any point of time, because we have scale color, if you wish to sort of kill those particles early, you can just play around with this F-curve and bring it in, and you can see the particles die earlier. So I can just bring it down so you can see what's going on. That's the beauty of having this float to curve, because it's so interactive, and you can just easily change the dissipation or buoyancy of your particle system. Now, remember that I told you that velocity is not the only method to create interactivity, you can do it with force. Now, before I bring in a force, I can just simply deactivate my velocity, and let's break up this particle using something more than initial velocity. And I'm just going to pause. We have something called location. So if I bring in location, we have shape location. So one reason that I brought velocity was to separate those particles. You can do it with location. So specify a fall off, a range, something to place particles within that volume or location. So shape location totally does the trick. So it gives you a volumetric shape like sphere. I can probably go to emitter update and expand it, go to spawn rate and give myself more particles to work with, let's say 300, maybe even 500, so you can kind of see the shape clearly. You can do sphere, you can do cylinder, and you can totally see the shape of the cylinder. If I increase the height to, let's say, 300, now you can see how easily you can create a cylinder looking particle emitter. You can do box, and of course every time you change those shapes you get all the sort of related properties to tweak the shape. For example, box size. If you feel like this box size is small, you can do totally 300 by 300 by 300, or you can create a rectangle if you want, and all of a sudden you get a much bigger box. You can do, let's say, torus, and of course you get the radius. So I can just do 10 and 200 to get a much larger, thinner radius, and it's more like a ring of particles, which is quite interesting. And again, you always have transform if you wish to, let's say, rotate it. So I can do axis angle and say, all right, I would like to rotate that. I'm now rotating it in y-axis, so I'm creating a ring like that. Now, let's say I'm going to switch that to good old sphere, because there is a lot that we can do with this sphere right here. Sphere distribution, random and direct, which is actually going to create that for me. I can go in here and change the V position. I can change the radius position right here. With U position, you can see that you get that a lot, where you get this linked value. It says it's linked to the emitter. So if I play, it's going to actually complete the ring. So this gives you the cue that, all right, it's been linked to the emitter, and age, or as you go through the life cycle, is going to complete the picture for you. You can click on this and sort of change that. Float to curve again is an option, where you get a curve into your curve editor panel and you can play around with it. I'll let you guys have fun with this shape location, but for now, let's move on to the next chapter and explore forces. So now we explored how to simply move particles using add velocity. Why don't we try force fields? Force fields give you much greater tool set and move part to the in for you. You can click on this and sort of change that. Float to curve again is an option where you get a curve into your curve editor panel and you can play around with it. I'll let you guys have fun with this shape location, but for now let's move on to the next chapter and explore. Explore forces. So now we explored how to simply move particles using add velocity. Why don't we try force fields? Force fields give you much greater tool set and options to choose from. So for now, I'm going to deactivate add velocity. So if I just rewind and play, I'm really not getting anything. Particles just get created using spawn rate, and what I've specified to spawn rate, 800 particles right now. So let's think about it for a moment. Where do we need to add force field? Because based on where you put the force field, it's going to either work or doesn't work for you. Let me just switch that to torus so we get a much better result when we add a force field. We go to update, particle update, and we can add force field here, and we don't need to have to add any post dependencies for it. You can see we have drag, we have curl noise, which is like a turbulence, works really well. We have vortex. Oh, let's use vortex. It's just fun. We can see that we have the amount, which is the intensity. I can lower it to, let's say, 100. I can just go rewind, play, and you can see vorticity takes place. You can have more modules. I'm going to stop, go to particle spawn, just fun. Dependencies for we add a for, because based on where you, if I just rewind and play, I'm really not getting anything. Particles just get created using spawn rate, and what I've specified to spawn rate, 800 particles right now. So let's think about it for a moment. Where do we need to add force field? Because based on where you put the force field, it's going to either work or doesn't work for you. Let me just switch that to torus, so we get a much better result when we add a force field. We go to update, particle update, and we can add force field here, and we don't need to have to add any post dependencies for it. You can see we have drag, we have curl noise, which is like a turbulence, works really well. We have vortex. Oh, let's use vortex. It's just fun. We can see that we have the amount, which is the intensity. I can lower it to, let's say, 100. I can just go rewind, play, and you can see vorticity takes place. You can have more modules. I'm going to stop, go to particle spawn, shape location, and tighten this torus. So probably put 5 for this 150 for radius. I'm just going to lower it to say 50, just to be able to get a much better result. Right, it's more like a galaxy-ish looking. Fine. While we added, why don't we add colors? With colors, I tend to put them in particle update as well. So just simply search for a color, and this color is going to overwrite scale color. Always think about that, because again, it's a stack that we're dealing with in a sequential order, top to bottom. So whatever you put at the bottom will overwrite the top. So it will overwrite this node. In color, we're dealing with the same thing. We're dealing with scale alpha, and we're dealing with color. You may say, Reza, are we going to get something like flow to curve with this one? If you click, you get color from curve. And if I go in there, the top is the color and the bottom is the opacity. So if I move this bottom chip, I will play around with the opacity. So I can just make it, this is the start of your particle system, this is the end. I can sort of change the opacity. You can see how it impacts within the preview window. And this one is actually the color itself. I can double click on it and say, when I start, I want these colors to be orange. You can add colors, so you can just click and say, well, as we move through, I would like these colors to turn to red. And you can see at the beginning, it's orangey looking. As we moving, it's red. You can do, so kind of go in here and swap and say, all right, no, you know what? I changed my mind. I want the beginning to be red. And you can see the feedback live. And as we go through it, I just want that to be orange. And you can add another one and say, you know what? After that, I want that to turn to pink bluish. And you just play around with the range as you go. You can play around with opacity to give this more life to the life cycle, or you leave it as is and start tweaking those colors. So that's basically it. It's just really, really easy, really fun, quite simple to play around with. Let's say you want to add chaos to the whole system. So particle update, I can go into forces and I can just say, you know what, I would like to add a curl noise to it. And curl noise simply adds chaos. Noise strength, I can just zoom in so you guys get to see what's going on. I can set down to 50 and you can see there's a little bit of chaos happening. Some particles shoot off to different angles. You can lower the noise frequency to see it in a more exaggerated way. And you can see we give it a little bit of a bend that is happening right now. So a lot can be done. I can go in there into initialize particle in my particle update, initialize particle. I can play around with min and max, so I can make the min 2 max, let's say 10. I can go to spawn rate and bump it up to 2000 or let's say 4000 particles and just have fun with it like that. That can be done. I can go in there into initialize particle in my, some particles shoot off to different angles. You can lower the noise frequency to see it in a more exaggerated way. And you can see we give it a little bit of a bend that is happening right now. So a lot can be done. I can go in there into initialize particle in my particle update, initialize particle. I can play around with min and max, so I can make the min 2 max, let's say 10. I can go to spawn rate and bump it up to 2000 or let's say 4000 particles and just have fun with it like that. So a lot you can do at the same time. You can switch to unlit to see the colors only and see the result. And it's just one of those things that there is no end to it. Just a quick note, if your machine starts struggling with your spawn rate and you feel like you've got a decent graphics card to swap your calculation from CPU to GPU, you totally can. You can go to GPU compute sim and it says, well, you know what? The bounds mode is dynamic and it only works with CPU. You can just switch to fixed, and if I play now, I'm now playing via my GPU. So that's pretty much it. How you add interactivity using, so I'm just gonna move this one a little bit here. I can probably go into curl noise and start tweaking stuff here and there. And you can see I'm coming up with some fun results. I'll let you just have fun with it. You can combine that with add velocity. So I can go add velocity, set it in cone, and you start sort of playing around with this, with colors. So I can go to colors and say, you know what, I just want to turn that to something. You have linear sRGB to play around with, and that should really do the trick. So I'll let you play around with this and get all sorts of fun results. Once you're happy with it, you can just simply save your particle and just drag and drop it in and see the results like so. So hopefully this is going to give you all the basics you need to know about Niagara system. We barely scratched the surface on this topic, and that's why I thought having this session is quite necessary to be able to explain the main building blocks, explain the core components of Niagara, and hopefully from next and future lessons, without being worried or too concerned about, oh, we don't know what module is or we don't know what Niagara system is, we can just focus on specific effects and look dev and just have fun with the system. I really hope you found this video useful. Please go back, try different modules, have fun with it. I'm 100% certain that you'll come up with something much better than this. Of course, this will do for just the introductory session. And thank you again for all of your support. Follow us on Twitter and Instagram and Reddit, and support us through Patreon. Thank you so much, and see you guys in the future lessons.
How's it going, everybody? Jesse here with Redefine Effects, and today I'll show you how to emit smoke and fire out of your animated character. Let's jump right into it. Alright, so first you need a character. You can download it from Mixamo, and just particle source, rename noise for these simulations. Under particle spawn, you can for skeletal for reproduction to be born. Right now what's happening under set, you can see our scene. Make sure that it's at the origin, so again XY system in your outliner, and drag it on top of your character skeletal mesh, which is the walk forward, and click on none. This way they're linked together, and now when you select simulate and start the simulation, you can see that they're perfectly attached and it's already working, right? So this is basically the setup. You can just improve how the simulation looks from here. So we can extend our grid on the y-axis. I'll just do 1000. So inside of the templates, there are some user parameters set.
Let's learn how to use the Niagara basics in C++ code and Unreal. So I've got two actors here. The yellow is code and the blue is blueprint. I haven't wrote the code yet, but to show you what we will be building, I've implemented it in blueprint first. So as you run up close to this, it overlaps, plays a confetti particle, and if you keep overlapping, it doesn't play it until it's completely done. This is pretty straightforward in blueprint. There are a few more things you need to consider in code. But in blueprint, I just have this active begin overlap, and I have a box collision that will be overlapped with. Now we want to do the same thing in code and see how to get that working. So what we will do is we'll go to the code class here, and right now it's just an empty actor. We have actor begin play tick. Hop over to begin play, and you can see that it's doing basically nothing yet, and tick is doing nothing yet. So the first thing we want to do is create an event for when we overlap. So in code, this is done by overriding virtual methods. So I will implement virtual methods and type overlap, notify actor begin overlap. Now we have our overlap virtual, and I'll clean this up a little bit.